ഓക്കെ. അതിലേക്ക് 2 ഇൻസ്ട്രുമെന്റ് ഉണ്ട് തോന്നുന്നു. 2 മൈക്കിന്റെ ഒരു മൈക്ക് എക്കോ ഉണ്ടെന്ന് മാത്രം. ഓക്കെ. അതിൽ ഇങ്ങോട്ട് ചെക്ക് ചെയ്യൂ. കുഴപ്പമില്ല, നിങ്ങൾ സംസാരിക്കൂ.
എനിക്ക് സംസാരിക്കാനേ പറ്റില്ല.
ഓക്കെ ഓക്കെ, നോ പ്രോബ്ലം. ജോയിൻ ചെയ്തവരുടെ റിക്വസ്റ്റ് ഉണ്ട്. നമ്മള് ചില ആളുകൾ ചിലപ്പോൾ പ്രസന്റേഷൻ മോഡിലേക്ക് പോകുന്ന കണ്ടിട്ടുണ്ട്. പ്രസന്റേഷൻ മോഡ് വന്നു കഴിഞ്ഞാൽ നമ്മുടെ പ്രസന്റേഷന് ബുദ്ധിമുട്ടാവും. അപ്പോൾ അതിലേക്ക് പോകാതിരിക്കുക. ഈ കണ്ടീഷൻ തന്നെ തുടരുക. മൈക്കും നമ്മുടെ ക്യാമറയും ഓഫ് ചെയ്തിട്ട് തുടരുക. ജോയിൻ ചെയ്ത് ബാബു വലിയ വീഡിയോ നോക്കാം. ഹലോ ഹലോ, ജോയിൻ ചെയ്ത് ബാബു വലിയ വീഡിയോ നോക്കാം. മനസ്സിലായി, ആളെ മനസ്സിലായി. ഓക്കെ ഓക്കെ, കോൺഫിഡൻസ്. ഓക്കെ റൈറ്റ്. ഓക്കെ, പ്രൊസീഡ്. ആദ്യം കൃഷ്ണ. ദാമോദരൻ സാർ. ദാമോദരൻ സാർ ഓക്കെ അല്ലേ? അതെങ്ങനെയാ പറ്റാതിരിക്കുക? അതിനകത്തേക്ക് അല്ല, അതിന്റെ മുകളിൽ ജസ്റ്റ് പ്രസ് ചെയ്യുമ്പോൾ ഒരു ഷെയ്ഡഡ് ലൈൻ വരില്ലേ?
ഷെയ്ഡഡ് ലൈൻ എവിടെ?
അതായത് നിങ്ങളെ സ്ക്രീൻ ആ ലിങ്കിന്റെ പച്ച നിറത്തിലുള്ള ഭാഗത്തല്ലാതെ, വെള്ള നിറത്തിലുള്ള ഭാഗത്തല്ലാതെ അതിന്റെ പുറത്തൊന്ന് ക്ലിക്ക് ചെയ്യുമ്പോൾ മൊത്തം സെലക്ട് ചെയ്യുന്ന രൂപം വരും. എന്നിട്ട് മുകളിലെ ഷെയർ ബട്ടൺ കൊടുത്തു കഴിഞ്ഞാൽ അതിന് വർക്ക് ചെയ്യും. തീർച്ചയായിട്ടും.
സാർ ഇപ്പം ഫേസ്ബുക്ക് ലൈവ് പോകുന്ന ഡൗട്ട് ഉണ്ട്. പക്ഷെ ലിങ്ക് എങ്ങനെയാ കിട്ടാൻ എനിക്കറിഞ്ഞൂടാ ഫേസ്ബുക്ക് ലൈവിന്.
നമ്മളതിനകത്താ, അത് കുഴപ്പമില്ല. നമ്മളത് യൂട്യൂബിലാണോ ഫേസ്ബുക്ക് ലൈവിലാണോ രണ്ടും പോയിക്കൊണ്ടിരിക്കുന്നത്. നോക്കട്ടെ, കുഴപ്പമില്ല. എങ്കിൽ നമുക്ക് മാതൃക നോക്കാം. ഇല്ലെങ്കിൽ എന്തെങ്കിലും പ്രയാസത്തിന്റെ ഫേസ്ബുക്ക് കട്ട് ചെയ്ത് യൂട്യൂബിൽ കേൾപ്പിക്കുക, കുഴപ്പമില്ല. എന്ത് നോക്കട്ടെ. ഓക്കെ, എന്തെങ്കിലും ആവശ്യം ഉണ്ടായിരുന്നു വിളിച്ചാൽ മതി. ഓക്കെ.
സാറിന്റെ വീഡിയോ സ്ക്രീനിൽ എടുക്കുന്നത്
30 Spacecraft and a Man. It was April 2015. The center was poised to implement the productionization of spacecraft in its true sense. With this challenge on board, the winds of change were blowing over ISAC. There was change at the helm of affairs at ISAC, with Dr. M. Annadurai taking over mantle as Director ISAC on 1st April 2015. Looking back today, as he lays down his office on superannuation, the daunting task of building 30 spacecraft including 6 student satellites in 40 months, beside 2 to 3 spacecraft being in the final stages of readiness, presents a scenario of productionization having completely ushered in the center.
Good afternoon, sir.
This achievement, coupled with technology developments in forward area of satellite technology and infrastructure growth and a myriad of other activities, stand out as scintillating plume in his cap of many achievements.
Oh, very good. Oh, 25. That's a very good number.
Very good number.
To begin with, even at 245.
Yes.
Mahilswamy Annadurai was born on the 2nd of July 1958 in Kodavadi near Pollachi in Coimbatore. Mahilswamy Annadurai had his schooling in his native village Kodavadi. He obtained a bachelor in engineering degree in the year 1980 from the Government College of Technology, completed his master's degree in engineering during 1982 from PSG College of Technology, and a PhD from Anna University of Technology. He joined ISRO in 1982.
Very nice. Good.
In his early days at ISAC, he was the team leader for development of software for satellite simulator. During the period 1988 to 1993, he had done incredible work as spacecraft operations manager for IRS-1A, IRS-1B, INSAT-2A and INSAT-2B. During the period 1992 to 2005, he led the ISRO's mission team as mission director and managed 10 INSAT missions. During the period 2004-2008, as the project director for ISRO's first lunar mission, Chandrayaan-1, he led a team of engineers and scientists that designed and developed a lunar craft with 11 scientific instruments on board from ISRO and NASA, ESA, JAXA and Bulgarian Academy of Sciences for chemical, mineralogical and photogeologic mapping of the entire lunar surface at high spatial and spectral resolutions. The project was realized within the time frame stipulated and the budget granted. The project has won many appreciations and national and international awards, including the prestigious Space Pioneer Award 2009 for its innovative cost-effective design, international cooperation and the historical discovery of water on the moon.
Sir,
In 2011,
Sir,
Dr.
Srikumar sir,
Annadurai
this is
took
a joint,
over
sir.
as Program Director
good.
of Indian Remote Sensing,
Navalgund sir
Space
is also
Science
joined now,
and
sir.
Small
Welcome,
Satellites
sir.
Program.
Welcome.
He was the
Very
driving
warm welcome,
force
Dr.
behind the
Navalgund
successful
and Dr.
realization
Srikumar.
of many state-of-the-art satellite projects, including Mars Orbiter Mission, Resource Sat 2, Megatropics, RISAT-1,
Sir, your
Saral,
mic is
etc.
muted, sir.
Under his leadership
Sir, I
as
think,
Program
mic of
Director,
Navalgund sir is
India's
muted,
first
sir.
interplanetary mission to planet Mars, Mars Orbiter Mission, was meticulously planned and realized.
Oh, so nice of you,
The
sir.
scintillating
How is
success of MOM has brought unprecedented
So
global
nice-
accolades,
so nice to
spiraling
see after
India
a long,
to the
long
pinnacle
time.
of glory.
Put my mic on silent for a moment.
Within a few days of taking over as Director Isaac, he took several initiatives for effective project management and overall organizational growth and development.
Rangarajan sir, warm
Unique
welcome.
project management techniques such as satellite project lifecycle
Mic is muted,
dashboard
sir. Mic
and
is
photo
muted. Just on
gallery
it and-
of ongoing center activities in Samvad web portal for better transparency
Hello,
and quick
okay.
dissemination
Is
of
it okay?
information to
Okay,
all
sir, it's okay,
concerned
it's okay.
were launched by Dr. Annadurai. He envisioned building of 10 spacecraft a year through his unique concept of Pancharatna.
Then what is the Pancharatna? I think only very people talked about that. And probably in the dashboard also, so we are trying to indicate, I'm trying to introduce a wider audience, okay, because as I told here, everyone has the reason to contribute for these Pancharatnas.
Hey,
Once you
now-
identify what is this Pancharatna, that name, whatever it is that, either in terms of the purchase file, either in terms of accounts clearance, either in terms of security clearance, I think this Pancharatna should get a priority.
Which in course graduated to Navaratna, meaning 9 spacecraft AIT at any given point of time.
1, 2, 3, 3,
Project
2, 1, can you hear
Lifecycle
me?
Management Compliance Framework, Milestone Charts, Project Monitoring Committee, Subsystem Realization Task Team, Subsystem Workload Analysis, Isaac Vision 2020 and beyond, infrastructure planning, etc.
Good
are a
afternoon to
few
you.
among the various tools introduced by him for effective project management and strategic planning. It is perhaps the first time that such an integrated approach to planning project, infrastructure, production was adopted in the center. Frequent visits by Director Isaac and other key functionaries to labs and work spots not only hastened the activities but
Namaste,
also
Srikumar
provided
also.
the much needed thrust and
I think your
motivation to
audio is
employees.
muted.
Yeah. Sorry. Very nice to see you after such a long time.
I know. Guys, that's all thanks to Good TV, all of us are
Yeah.
getting.
Hello, Dr. Navalgund. Hello. I'm all right, yeah.
Another eye. No, we can't see. No, I don't see.
30 spacecraft and a man. It was April
No, it's
2015.
okay.
The center was poised to implement the productionization of spacecraft in its true
See, in
sense.
Tamil, we call it Mappala
With
Guru.
this challenge on board, the winds of change were blowing over Isaac.
So one thing, sir,
There
normally
was change at the helm of affairs at Isaac, with
Yes.
Dr. M. Annadurai taking over mantle as Director Isaac on 1st April 2015. Looking back today, as he lays down his office on superannuation, the daunting task of building 30 spacecraft including 6 student satellites in 40 months, beside 2 to 3 spacecraft being in the final stages of readiness, presents a scenario of productionization having completely ushered in the center. This achievement, coupled with technology developments in forward area of satellite technology and infrastructure growth and a myriad of other activities, stand out as scintillating plume in his cap of many achievements. Swami Annadurai was born on the 2nd of July 1958 in Kodavadi near Pollachi in Coimbatore. Swami Annadurai had his schooling in his native village Kodavadi. He obtained a Bachelor in Engineering degree in the year 1980 from the Government College of Technology, completed his Master's degree in Engineering during 1982 from PSG College of Technology,
Good afternoon, sir. Good afternoon.
and a PhD from Anna University of
Sir, I will attend the
Technology.
meeting.
He joined ISRO in 1982.
Kids also will join, sir.
In his early days at ISAC, he was the team leader for development of software for satellite simulator. During the period 1988 to 1993, he had done incredible work as spacecraft operations manager for IRS-1A,
So they will also join.
IRS-1B, INSAT-2A and INSAT-2B. During the period 1992 to 2005, he led the ISRO's mission team as mission director and managed 10 INSAT missions. During the period 2004-2008, as the project director for ISRO's first lunar mission, Chandrayaan-1, he led a team of engineers and scientists that designed and developed a lunar craft with 11 scientific instruments on board from ISRO and NASA, ESA, JAXA, and Bulgarian Academy of Sciences for chemical, mineralogical and photogeologic mapping of the entire lunar surface at high spatial and spectral resolutions. The project was realized within the time frame stipulated and the budget granted. The project has won many appreciations and national and international awards, including the prestigious Space Pioneer Award 2009 for its innovative, cost-effective design, international cooperation, and the historical discovery of water on the moon.
Trichy and now he's retired, but I don't know whether he was with the ECE department and later
In 2011,
there as the dean.
Dr. Annadurai took over as Program Director of Indian Remote Sensing, Space Science and Small Satellites Program. He was the driving force behind the successful realization of many state-of-the-art satellite projects, including Mars Orbiter Mission, Resource-Sat-2, Megatropics, RISAT-1, Saral, etc.
Okay.
Under his leadership as Program Director, India's first interplanetary mission to planet Mars, Mars Orbiter mission, was meticulously planned and realized. The scintillating success of MOM has brought unprecedented global accolades, spiraling India to the pinnacle of glory. Within a few days of taking over as Director ISAC, he took several initiatives for effective project management and overall organizational growth and development. Unique project management techniques such as Satellite Project Lifecycle Dashboard and Photo Gallery of ongoing center activities in Samvad web portal for better transparency and quick dissemination of information to all concerned were launched by Dr. Annadurai. He envisioned building of 10 spacecraft a year through his unique concept of Pancharatna.
Then what is the Pancharatna? I think only very people talked about that. And probably in the dashboard also, so we are trying to indicate, I'm trying to introduce a wider audience. Okay, because as I told here, everyone has the reason to contribute for this Pancharatnas. Once you identify what is this Pancharatna, that name, whatever it is there, either in terms of the purchase file, either in terms of accounts clearance, either in terms of security clearance, I think this Pancharatna should get a priority.
Which in course graduated to Navaratna, meaning 9 spacecraft AIT at any given point of time. Project Lifecycle Management Compliance Framework, Milestone Charts, Project Monitoring Committee, Subsystem Realization Task Team, Subsystem Workload Analysis, ISAC Vision 2020 and beyond, Infrastructure Planning, etc. are a few among the various tools introduced by him for effective project management and strategic planning. It is perhaps the first time that such an integrated approach to planning projects, infrastructure, production was adopted in the center.
Sir, I am calling now, sir.
Frequent visits by
good,
Director
good, good,
Isaac
good.
and other key functionaries to labs and work spots not only hastened the activities but also provided the much needed thrust and motivation to employees.
Yes, welcome,
Yes, sir.
welcome, Dr. Balabhumi. Wow, just on time.
He's a mission man. I know that.
Ah, exactly, man. You man.
He effectively met the organizational need to restructure the center in time with the demands of the activities by carving out new areas like MISA, CMMA, and SRQA. A number of knowledge management initiatives such as Isaac Innovation Forum, Isaac Innovation Club, Spark, and lesson learned workshops were taken up during his tenure as director to inculcate the culture of innovation, improvisation, and excellence. A path-breaking development during his tenure was signing of contract with a consortium of Indian industries for outsourcing of AIT of 2 satellites. Taking forward, the center also signed parallel contracts with 3 vendors for the outsourcing of AIT activities of different types of satellites. With this, the long-standing vision of end-to-end satellite realization through industry will soon become a reality. This apart, a contract has also been signed with a few vendors for bulk production and supply of avionics packages on an end-to-end basis to feed our satellite projects. Many other contracts aimed at enduring a continuous supply chain of various subsystems and components were also put in place, which includes outsourcing of harness fabrication, solar panel and battery fabrication, deployment mechanism, alignment activities, etc. Now technology developments are being pursued in the center, both in project mode and non-project mode. Developments of note during his tenure include unfurlable antenna for GSAT-6, UVIT and SSM payload for AstroSat, I6K modular bus platform, heat pipe embedded large payload panels, large size solar panels, modular power electronic system, I6K spacecraft, indigenous bus bar, GRASP, geostationary radiation spectrometer payload for GSAT-19, indigenous satellite positioning system for Cartosat-2 series, etc., indigenous TM and TC processor, total automation of spacecraft checkout phase 1, passive vibration isolator for reaction wheels, upgradation of high bitrate data transmission system, high capacity memory modules and encryption systems, high accuracy onboard sensors, robotic arm for docking experiments, fiber optic gyros, high precision sensors including critical technology developments for Chandrayaan-2 are some of the other milestone technology developments during his tenure. URSC has
Santosh sir.
I think he's muted.
Sir, unmute it.
Okay, thank you. Thank you, Sushil Dimash. Good evening to all. Can you hear me?
It's okay. You think, sir.
That's one small step of man, one daily for mankind. I remember the words of Neil Armstrong on 25th July 1969. That was the achievement of mankind in the exploration of universe. Balabhumi, the children's magazine from the house of Balabhumi Printing and Publishing Company, is keeping keen interest in nurturing the curious mind of kids by providing them tips of knowledge, prompting them to explore the enigmatic world of science. We are happy to collaborate of 15th Moon Day celebration with the UL Space Club, which is publishing under the umbrella of ULCCS, the largest construction company in our nation. ISRO made our country to keep a prestigious position among developed nations in the country, the continuous success in space exploration. We on this Moon Day proudly presenting a person who put his landmark role in the development of space science. Padma Dr. Mayuraswamy Annadurai, Moonman of India, is a multifaceted personality, a space scientist of international repute, technical leader of par excellence, able administrator, a good orator, writer, and a humanitarian. He successfully executed internationally reputed projects like Chandrayaan-1, Mangalyaan, India's space mission to the Moon and the Mars. Currently holding the responsibilities of Vice President of Tamil Nadu State Council for Science and Technology and Chairman and a recipient of several international awards. I proudly invite Honorable Padma Shri Dr. Mayuraswamy Annadurai to this webinar, and he will make a wonderful interaction with us. Sri Ramesan Paleri, the philanthropist and missionary, is leading ULCCS, the great organization not only in the infrastructure development activities but also in field like IT, skill development, charity, nurturing programmer of bright students. Bhadbhadananda Education Project is engaged with this activity and nurturing around 5,000 students directly and a large number indirectly. I invite Sir Ramesan Paleri to this webinar, who is presiding this function. Regional Science Center and a Planetarium, Kozhikode, is a nurturing ground of science education in Malabar region. We are proud to have an enthusiastic king of wisdom as the captain of this institution of science importance. Sri Manash Bakchi, he who wondered the students and scholars with this simplicity and open-mindedness. A warm welcome to our proud Manash Bakchi sir, who is chief guest in this occasion. As a privilege and honor, we have three more eminent scientists with us. Dr. Ranganath Navalgund, former director of National Remote Sensing Center and Space Application Center ISRO. He played an important role in the establishment of several remote sensing application centers in different states of country and the establishment of national natural resource management system. Moreover, an eminent scientist with a meticulous track record is with us. A warm welcome to Dr. Ranganath Navalgund sir to this webinar. Dr. Srikumar is an astrophysics by training and is currently the advisor to the space science program of his ISRO. His postdoctoral research focused on the emerging area of observing the universe in the gamma rays using NASA's Compton Gamma Rays Observatory. After joining in ISRO, he became the director of Indian Institute of Astrophysics and retired from ISRO as director of Space Science Program. Warm welcome to Dr. Srikumar sir. Dr. S. Rangarajan is a satellite industry veteran with 40 plus years of experience in successive leadership roles in the public and private sectors. Dr. S. Rangarajan at present is the Chief Technology Officer He asked me USA, beside being an advisor to Wigden University. He was at ISRO 1978 to 2000, holding several important executive positions like Director INSAT, Director MPF Hassan. Welcome Dr. Rangarajan, and he is always cooperating with the UL Space Club and its activities with the past few years. For every endeavor, there should be high and visionary with a strong determination with organization capacity is needed. That is the cause of success story of UL Space Club, and that is our proud person, Sri E.K. former director of ISRO. He is the chief patron and mentor of UL Space Club. I invite E.K. at this function. Master Bharat Rijit, a national talent search award winner and student fellow of UL Space Club, is here to speak about the activities of Space Club. I make a warm welcome to him. Dr. Sandesh, EPA coordinator, UL Education, is making an overall review of this program. I invite him with great pleasure. Sri T. Damodaran, coordinator, Bhagavana Education Project, is expressing what of this great event. I also invite Sri T. Damodaran. Sri U.K. Ajil is the moderator of this webinar. I make a welcome to him. I also welcome all the scholars and students in the Google Meet platform and thousands of curious minds participants through Balabhumi.com Facebook page live. I invite Sri Ramesh Pareri to preside over this function. Thank you all.
Sir, thank you, Santosh sir. Before that, we want to know what is UL Space Club? What activities are going on here? This group admitted and joined here in this webinar is a heterogeneous group that composed of several scholars, scientists, and even students, and even some common people are there. They are really waiting for that, and also a lot of people are watching all over Kerala through Facebook, through Balabhumi Facebook Live. They are watching this program, and they want to know what's the activities going on here and what is UL Space Club actually.
Of telling you what UL Space Club is. But why is it that I, a student, is entrusted with such a responsibility? Considering the fact that the all-in-alls of UL Space Club like Kutti sir, Shajil sir and Damodaran sir are already part of this virtual dice. I believe that the reason is perhaps that experience gives you a great deal of ideas, and being a beneficiary of the club myself, I may be able to tell you about UL Space Club as good as anybody else. As the name suggests, UL Space Club is a club for students intensely interested in space science and astronomy centered at Kozhikode. All of us, especially in our childhood, have always been fascinated about all those things happening around in the sky above. Is there a single person who has never dreamed of touching the moon and the stars? Obviously, never. This fascination and the curiosity thus inculcated is the driving force not only for students but maybe is a general characteristic of humans as a whole. Such curiosity in children, if kindled, can one day result in them shining light all over the world. But the guidance they need for this is difficult to come by since schools are rarely equipped to do so. And UL Space Club is a voluntary effort to fill that gap. It all dates back to a former director of ISRO organizing exploratory classes in space science and technology in and around Kozhikode. There is no better way to describe this person other than his very own name, the lively, exuberant, and energetic Sri E.K. Kuti sir, who is the chief patron and mentor of US Space Club. But the times changed when he got the opportunity to interact with the students of the ULCCS sponsored Valpadananda HU project. These students soon received the opportunity to visit the Vikram Sarabhai Space Center Tumba and the Liquid Propulsion System Center Balebala and interact with the directors and scientists, creating a good impression on their potential. Thus, the seeds of UL Space Club were sown and it began flourishing in the rich soil of Kozhikode since the year 2016. Ever since then, numerous space camps have been conducted, the first of which was held at UL Cyber Park Kozhikode in 2016, entirely sponsored by ULCCS. Subsequent years have witnessed multiple space camps each year, most of residential nature, with the nights being used for skywatches. Partnering with the top educational institutions of Kozhikode, the University of Calicut and the National Institute of Technology Calicut, along with the critical interventions of ULCCS and the Regional Science Center and Planetarium Kozhikode, we successfully executed numerous events, including the world's maiden space drama staged at the University of Calicut. From the space camp at National Institute of Advanced Studies, Bengaluru, organized with Cinder by Nurture, we could visit ISRO centers like the UR Rao Satellite Center, Bengaluru, and ISRAC. In fact, we were even more fortunate when Padma Shri Dr. M. Anandre hosted us at UR Rao Satellite Center as its director. My friends and I are super excited to hear him once again. We also had the opportunity to interact with people as big as the former chairman of ISRO, like Dr. G. Madhavan Nair, Dr. K. Radhakrishnan, and Dr. A.S. Kiran Kumar, and even Wing Commander Rakesh Sharma, the first Indian in space. But all this seems so general. What is it that UL Space Club has to showcase, you may ask? The humblest answer I can give you is, well, myself. Just think of it. I, a bare 12th standard student, being able to address a dais and an audience of such a class is something that I absolutely cherish. So, what UL Space Club does is that it gives these opportunities to students who desperately need them. In fact, my dear Varun and I were bestowed with the opportunity of presenting a project of ours to the directors of BSSC, Dr. Somnath, and LPSC, Dr. Narayan, during our visit. The icing on the cake was when our brother, Master Abhinan PS, was invited by the very chairman of ISRO, Dr. A.S. Kiran Kumar, to visit Satish Dhawan Space Center Sriharikota as his guest and witness the launch of the PSLV C-38 from the Launch Control Center. Even with the outbreak of the pandemic, UL Space Club was not ready to hold back. The club conceptualized a weekly webinar series every Saturday and successfully organized its 9th session the previous Saturday. This has now culminated in today's event and will continually be organized every week. Several other initiatives have emanated from the student members of UL Space Club, leveraging on the capacity and skills they have acquired from the club. For me and my friends, well, UL Space Club has been an ocean of opportunities, but it's only worth it if we are ready to take it. So what I personally would like to say to the young people out there is that just grab such opportunities with both hands. And I would like to conclude by telling you that we promise all of you that UL Space Club will also be there for you. Thank you.
Thank you, Bharat, for your overview on this US Space Club. And it's time for the presidential address. We invite the chief of the Uralangal Labour Contract Society, the largest cooperative society in construction field in all over India, and it's engaged in all activities that connected with the human life. We proudly invite the chairman of ULCCS to preside over this function.
എല്ലാവർക്കും നമസ്കാരം. UL സ്പേസ് ക്ലബിന്റെ നേതൃത്വത്തിൽ നമ്മൾ ഇന്ന് 2020 ചാന്ദ്രദിനം ആഘോഷിക്കുകയാണല്ലോ. മനുഷ്യരാശി സമാനതകളില്ലാത്ത പ്രതിസന്ധിയിലൂടെ കടന്നുപോയിക്കൊണ്ടിരിക്കുന്ന കാലഘട്ടത്തിലാണ് നാം ഇന്നിവിടെ ഒത്തുകൂടിയിരിക്കുന്നത്. മനുഷ്യന്റെ പ്രയത്നത്തിലൂടെ, ശാസ്ത്രത്തിന്റെ ശരിയായ പ്രയോഗത്തിലൂടെ ഈ പ്രതിസന്ധി മറികടക്കാൻ സാധിക്കും എന്ന് ഞാൻ ഉറച്ചു വിശ്വസിക്കുന്നു. ഇത്തരം പ്രതിസന്ധികളെ മനുഷ്യത്വത്തിന്റെ പക്ഷത്ത് നിന്നുകൊണ്ട് അതിജീവിക്കാൻ കെൽപ്പുള്ള ഒരു പുതിയ തലമുറയെ വളർത്തിക്കൊണ്ടുവരിക എന്ന ദൗത്യം നമ്മൾ എല്ലാവരും കൂടുതൽ ശക്തമായി ഏറ്റെടുക്കേണ്ടതുണ്ട്. UL സ്പേസ് ക്ലബ്ബ് ഈ ദിശയിൽ നടത്തി വരുന്ന പ്രവർത്തനങ്ങൾ സമൂഹത്തിൽ വലിയ അംഗീകാരം നേടിവരുന്നുണ്ട്. കൂടുതൽ ശക്തമായ ഇത്തരം പ്രവർത്തനം മുന്നോട്ട് കൊണ്ടുപോകാൻ ഞാൻ നിങ്ങളെ കൂടെ ഉണ്ടാകും എന്ന് മാത്രം പറയാൻ ഈ അവസരം ഉപയോഗിക്കട്ടെ. To celebrate this lunar days, to share the message of the lunar day with the children, we have the most eminent personalities in the field participating in this webinar. I would like to extend my gratitude on behalf of the USS to Brahmasri, Dr. Annadhuri, former Director, URSC, ISRO, Sri Manat Bakshi, Operator, Regional Science Center and Planetarium Kozhikode, Dr. R.R. Navalgundu, former Director, Space Application Center, ISRO, Dr. P. Srikumar, former Director, Indian Institute of Astrophysics, Dr. Rangarajan, former Director, Master of Control of Facilities Center, ISRO. ഈ പ്രഗത്ഭരുമായിട്ടുള്ള സംവദിക്കാനുള്ള അവസരം നമ്മുടെ നാട്ടിലെ സാധാരണക്കാരായ കുട്ടികൾക്ക് ഇന്ന് ലഭ്യമായിരിക്കാൻ അത് അവരിൽ സൃഷ്ടിക്കാൻ പോകുന്ന സ്വാധീനം വളരെ വലുതായിരിക്കും. അത് ഈ നാട്ടിന്റെ പുരോഗതിക്ക് ഒരു പുതിയ മുതൽക്കൂട്ടായിരിക്കും. ഇത്തരം അവസരങ്ങൾ അവർക്ക് സൃഷ്ടിച്ചു കൊടുക്കുന്നതിൽ ശ്രീ ഇ.കെ. കുട്ടി സാറിനുള്ള നന്ദി USSന്റെ പേരിൽ ഞാൻ ഈ അവസരത്തിൽ അറിയിക്കട്ടെ. ഇത്തരം പ്രവർത്തനങ്ങൾക്ക് പ്രഗത്ഭരുടെ പിന്തുണ വലിയ ഊർജമാണ് നൽകുന്നത്. ഇനിയും ഇത്തരത്തിലുള്ള പ്രവർത്തനങ്ങൾക്ക് വേണ്ട പിന്തുണ നൽകണമെന്ന് അഭ്യർത്ഥിച്ചുകൊണ്ട് ഈ വെബിനാറിൽ പങ്കെടുക്കുന്ന എല്ലാവർക്കും എല്ലാവിധ ആശംസകളും അർപ്പിച്ചുകൊണ്ട് നിർത്തുന്നു. നന്ദി, നമസ്കാരം.
Thank you, Ramesh sir. Next is our turn for the chief guest, Sri Manas Bakshi, the curator of Regional Science Center and Planetarium Kozhikode. Regional Science Center and Planetarium Kozhikode is the nurturing ground for the students, scholars, and the common man that makes a bridge to the science, to the field of science, and to the common man. And there are a lot of nurturing programs are going on there. It is established 30 years back, but now that is flourished with a wisdom, a king of wisdom, that is Manas Bakshi sir. We know him with the depth and breadth of his knowledge. We know with several functions. We know it well, and we warm welcome Sri Manas Bakshi sir to make his chief guest address to this gathering. Welcome, Bakshi sir. Sir, it couldn't connect, sir. I think there is a connectivity problem with Manas Bakshi sir. Then, with the president's permission, I think we can turn to the next procedure. I think so. I will try to connect Manas Bakshi sir. We will make the defer that his chief guest address for a little bit later, and without wasting time, we will go to the next step. And we have 4 eminent personalities from ISRO here, and most of them are directors, and some of the eminent scientists who put India in the high realm of the realm among the developed countries in this world. So we are proud to be with you, sir. And Ragaraj sir is there, and our chief guest and proud of India, that's the moon man of India, Annadhuri sir is there, and we have Navalgundu sir is there, Srikumar sir is there. Lot of people are gathered here, and if I take an introductory speech and make them familiar to this gathering, that would be I think it would be a failure for my part. And because whatever thing I say, that maybe from the black and white letter in my paper, but I want to make it a live one. That's why that should be from the heart of the cooperation and a person he know them fully in his life and his career. That we have E.K. Kutti sir with us, and he is the eminent personality we know, and he is the leader and is the sole mentor and the chief patron of this US Space Club, and he is the co-associates of these eminent scientists, proud scientists of India. And I invite E.K. Kutti sir to introduce our chief guest to this occasion. Welcome, Kutti sir.
Thanks, dear Shajil. Today is a highly important day, not only for lunar enthusiasts, but even for people who admire adventurism. So, on such a day, we are blessed to have four giants of ISRO with whom I had a what you call blessed to work with. Before addressing them, I would like to say that we have a very good audience today across. Normally, we used to have around in and around Kozhikode, but this time it is across Kerala. But I believe there are few even from away from Kerala listening to us. And of course, this program is there live on Facebook, YouTube, etc. So, I first of all thank Santosh Vallikod for hosting this program and welcoming our guests. In fact, I am yet to meet Santosh Vallikod, and we will certainly do that. Balabhumi came forward and made this a very, very rich one, a very, very important one. So thank you, Santosh Vallikod. And Rameshan Paleri sir, our Ramesh Shettan, he is the father figure of ULCCS and he is a father figure for us as well. Our Rakshagan, our Rakshadhikari. Bharat, who spoke just now, you could get the depth of this boy, and he not only works as a student, he works as a worker as well. To make this function successful, he, along with his friends, Varun, etc., have done a fantastic job. Of course, Manas Bagchi is not being seen. There is some problem, it looks, some technical reach. And Manas Bhakti is one of the important person who keeps us inspired by his support and his encouragement. And coming to my own respectable ISRO colleagues, I know all of them for half a century. Maybe Sri Kumar came a bit late from NASA, but for that, all others I know more than half a century. They played varied roles in shaping me up as well. All four guys of ISRO together in one platform. That is Dr. Navalgund, Dr. Anadri, Dr. Srikumar, and Dr. Rangarajan is something a great blessing for the Space Club. So, coming to our today's talk by Moonman, Dr. Anadri. Anadri has been a person who he has been inspiring students after his return, in particular in Tamil Nadu. Probably the first time he's there in a Kerala audience, and he is known to the whole nation suddenly in 2008 when our Chandrayaan went up. And with its maiden flight success, a rare feat, he rose very high. He was the project director of Chandrayaan 1, and the conquest of moon is done by India. Before that, US did it. Not only they did it, 12 of their people stepped onto the moon, spent time there. Then Russia went, Japan went, China went, and European Space Agency. And India did it wonderfully under the leadership of Dr. Anadri. Anadri joined ISRO after his BE, ME, and PhD and has been involved in all the satellite activities of ISRO in ISRO Satellite Center, which is now known as UR Rao Satellite Center. He was part of developing, making, and launching 60 satellites, remote sensing, communication, science missions, planetary explorations, etc. He was also the program director for Mangalyaan, India's another pride, Mangalyaan. So in 82, he joined ISRO, left in 2018, and his contribution is so rich that he got a Padma Shri in 2016. Padma Shri award is something great, I need not say. He has a long list of awards and recognitions. Besides his PhD, he got BSc, doctorate from MGR University, Central University, Pondicherry, etc. And he has guided many students for PhD and postgraduate studies. Several publications are there at his credit, and he is also known for student development. In that context, he is the right person today for us to inspire our students. So I am very, very happy and proud to present Dr. Swami Annadure today to this audience. Sir, please address. Dr. Annadure, sir, please address.
Yeah, thank you. Thank you, Mr. Ruki, for a very, very nice and elaborate intro, whatever you given. Let me see how I can live up to that intro and expectations. So I have a good number of view graphs with me. So without doing much, just I will get into the help of the view graphs. Then, if time permits, I will come back in intro, something like that. Are you able to see my screen now?
No, sir. No, sir. No, sir.
Let me come back. Let me come back.
Okay, sir. It's yes. It's not for me. It's yes. Yes is coming. It's okay.
It's coming now. One minute.
But
is it okay now?
Yes, it's presenting, sir. No problem. It's coming.
Okay, fine. Okay. Yeah, sorry for a small hiccup. Today being the celebration, basically for the first the moon day. This is basically origin, if you recall, it started somewhere in May 25th of 1967. Formally, then President of US declaring US to commit itself to achieving the goal before the decade is out of landing a man on the moon and returning him safely to the earth. I think that time it looks like very, very tall order commitment US was making. It was looking like that. But today, when Bharat was making that statement from Indian soil, somewhere in Kozhikode, so that you can see how that very, very, that two-line catchy thing, it was looking at tall order, now it has gone, how it got award. How it got award, I think that is the thing, because it is not only the US gone to the moon, it's the humanity gone to the moon. It is basically raised the aspirations of the billions of the people across the globe. I think that is the real story of it. That is one of the reasons every year I think this being celebrated across the globe. With this thing, just I will keep running through how this evolution took place, and I will try to put it in a slightly different perspective of how my lifeline was going all through. Like Bharat, I also could see myself somewhere in the line. Almost around that time frame of where is Kennedy has spoken. From that time frame onwards, I was somehow or other in the lifeline of this moon. Okay, this is how it has happened. Probably I will try to touch upon. Now you look at here. Yes,
July 16th, whatever he told on 61, it has germinated into the real thing within the decade itself. July 16th of 1969, it launch took place, and 21st of the same month, 1969, along with the American flag, Armstrong standing. It's a really historical event. That is the one we are celebrating today. Now you look at here, last year I had opportunity and the 50 years of moon landing. Across India, many people have been collected students and addressing to them why the moon landing is the one which has made a lot of good the school students and very many the people for science. I think attracting the science and doing, and towards that, I think they were trying to connect me. I think even the last year I was in US Consulate General talking with that, but there I was trying to connect how India and US the go journey started. I was trying to put that. Probably I will try to touch upon while we're talking about here. Mostly the continuity of what I talked now versus what today I'm thinking about that. Look at here. This is you can think about my younger age. Okay, basically whatever the first two biographs, whatever I told, whatever Kennedy has told, their aim of that full decade, and finally, though we didn't see in a TV that time, it was Akashwani, not even R&D radio. We are listening the commentary of the Armstrong landing. So until then, good number of newspapers also was coming out. America was trying to land there. So that when that being in the background, so this is the school. There is a diversion. Diversion means which way to go. Go as a routine school student or have some a new way of doing. I think that down the line, next paragraph will tell what does that mean. So this me putting in the light frame today, maybe Bharat and the other team, they may be into that similar stream. But just in connecting myself into this particular domain. So when you talk about this, hopefully you're all here listening to me now. Hope my audio and video are able to see, correct now?
Yes,
Yes, sir.
sir.
Okay, sir. It's okay. Okay.
So now look at here. This is in a second standard. There is a competition. Competition means in the class, our Kodavadi village had a big lake of 400, 500 acres, big lake. In summer, that water will dry, and the clay will be such a way good clay available there. So we are supposed to make out of the clay what is the new items. We are supposed to come out with the some items to show the next day the classroom. So then teacher will select will select it one, and that student will be that day will be remembered and will pattered, and possibly if everything is good they will give a compliment, some pencil or pen. I think something like that was the thing. So nominally what happens is even though when we are second standard, such a things making it difficult, maybe mother or the elder sisters, they will help to make this to happen. But me being the eldest son, and this will be a bit difficult. And my father always used to tell me even that time I should do that rather than assignments being done by the from the house. And over and above that, I had a good number of siblings also with me. So put together, I think this is not the possibility. So what I did that time was a simple, very simple thing. It may look like, because as I told now, that somehow that Ambulivama reading and Kennedy's speech and Armstrong about to land, all the things put together, moon was become a center stage of that toy. And the good thing is that other side of the moon, along with that, I think that time it's a 2 paise, they will go, or for the flag day, they will give the flag, very small flag, which we can wear in that shirt. So that putting it there, and a small man-like system, putting it there, as if Indian flag on the other side of the moon. I think this is what I shown there. So that brought me in the whole class. Class teacher identified this is first of all original thing. Second thing is thinking a new way of making expressing himself. I think that's what he was trying to tell that, and that brought me a 2 paise pencil as the reward for that day. So that journey is the one picked up down the line, and that is the story of Padma Shri of recent thing, and some more awards of late from Tamil Nadu and other place, whatever I got is basically started from this thing is concerned. So then fast forward, this is initially I told 61. Similarly, we also had a similar thing back in India, where I think this came in the newspaper. First ever time media showed the possibility of ISRO's mission to the moon. So basically, the technology day, I think May 11th is like our moon day, our July 21st. We are talking about National Technology Day is May 11th. And May 11th, whatever then Chairman ISRO, Dr. Kasturangan talked about, he talked about what various accomplishments of ISRO. And down the line, I think the last view graph, I think which many of the people have contributed, that was indicating a possible technical feasibility of using a PSL mission, a modest 140 kilogram satellite around the moon, or 275 kg flyby mission. I think that's talked about that. But main thing is what Kennedy told, within the decade, US will make manned mission to the moon and safely bring them back. And this is main thing is, you read this, working out the mission objectives and payloads would take time. And if all goes well, it could be a reality in 2008. This was told by, not by President of India, it was told by Chairman of ISRO. And that indication is very, very modest satellite. But even then, he told this possibility exists 2008. I think you all very know. And we made this mission in 2008. The story unfolds how it is. And that is not a very, very modest 140 kg satellite. Just to make a presence now, it made the historical discovery of water on the moon, carrying a good number of science instruments, state-of-the-art science instrument, and it definitely made a history. The same year of 2008, what has been told. Okay, and the story unfolds here. And here, between, as I told myself as a student, and all the way to when we started about 99, he told, and it took another 5 years policymakers to realize yes, it can be done. And in 2004, the project has been identified. So this particular thing has been captured. Of course, this is another feature film. Again, it happened in Kerala only. And this film, I just have taken just a minute of thing, which will fast forward whatever I told starting to now. I think you will, along with my story. So this 2004, Kodavadi village, Tamil Nadu. I think this is how my father is talking. And this is depicted by one of the actor in Kerala. And this depicts my mother, my younger age. I'm listening to, as I told here. This is given in the movie. And this scene is basically trying to tell, I went to my native village and telling to my father and mother, I have been identified as the project director for Chandrayaan 1. So now, yes, now 2004, given the Chandrayaan 1 project director. So now, there actually, as a member secretary, I was also the part of the project report to make. But now, team has been given, very young team, relatively young, and I myself was not more than 45 years around that time. So knew whether that team was identified because at least during their time frame in ISRO they were able to realize the mission. So everyone was given at least some 15 years more. Their service in the ISRO was identified, and within us we are discussing whether we will just simply follow the project report as given in the Chandrayaan 1 realization, because that to realize it within that budget, within the schedule, what is possible with us has been identified as a project report. But now, whether we can do like that or we can do initiative, because as I already told Mr. Koti, 69 missions have gone to the moon prior to that. And they have even landed on the moon. They actually come back. Many things happened there. But what we are going to do, we also run case, and our mission is very, very modest. Our even PSLV was not well proven that time. And with all these things, what we are going to do, I think there was a lot of discussions was going through that. And we thought, I think, to make our presence felt, I think we should make a new initiative. What is the new initiative? I think that will come like this. So basically, you look at here, before that 16 missions have gone, and nobody has discovered water on the moon. Is it possible for us to give a decisive answer? No water on the moon, not for looking for water on the moon. Look, go for the whole moon, using a remote sensing instruments and trying to decipher what the surface contains, chemical mineralogical mapping of the whole moon. When the process of that, is it possible for us to tell nowhere water on the moon? Okay, this is like more like presence of ether, absence of ether. A lot of experiments and went, and they have a big ambiguity. Something similar you can think about that. And with that, our suite of instruments as was available that time, a very, very modest spacecraft configuration, whether to realize this or anything else we can do. That's what we are thinking. And when this came, we thought something else, somebody else from others also, if it comes, probably we can help, because here, except a high energy X-ray instrument, which probably would have shown a possibility of the transportation of the systems to the lunar, our polar regions, because we thought if at all water would have been there, it would have been in the poles. And in other regions, with the sunlight hitting it very hard and no atmosphere being there, the presence of water was a big question mark in the sunlit regions of the moon. So if at all that there, only that will come. Other instrumentations very difficult to decipher anything there. Whether any other instrument can look for this answer also was thought about that. So then the announcement of opportunity for one additional science instrument. This is one additional science instrument for the not more than 10 kg of mass and not more than 10 watts of power it should consume. But it should supplement and complement our overall mission objective. This is how it is put there. But to our surprise, 26 offers came across the globe. Okay, and that too with this two glaring thing is one from Dr. Carla Peters from JPL Brown University, another one from Dr. Paul Spudis of APL John Hopkins University, supported, both of them supported by the NASA, technically two different instruments. Both were looking for the possibility of water on the moon. Okay, this is the really eye-catching thing. But here the issue is, we originally told we will carry only one science instrument, not more than 10 kg. But now these two instruments have come. And not only that, they personally called me 2 alternate days asking for an opportunity, competing opportunity. When that came, I thought somehow we should accommodate both instruments. Personally, I thought somehow we should accommodate. So we went through that, but how accommodating both the instruments from US, very difficult. And both put together individually, each one of them itself was weighing more than 10 kg around that time. So even if we bring them both less than 10, technical challenge, and accommodating both instruments from NASA is another tough instruments. So we went through a totally different, again, as happened in second standard, instead of going a routine path of taking, what is the new initiative we can take in? So out of 26 instruments, we within our technical team have gone through that, and what all can be done there. So then we told, instead of 10 kg, we can carry 35 kg instruments. We have taken a challenge. And in that process, we told, you let us bring in as many instruments as possible. We can carry another 5 or 6 instruments. Equally, another 6 instruments you can carry. I was pretty sure somebody selects out of 26. In the 6, definitely this instrument will come first too. Definitely because of the PI merit, because of the agency organization backing, and because of science and technical merit, definitely this can come together. I think that's what happened there. And accordingly, you look at here, ISRO being at the center stage, a modest satellite of our Trangan talked about 140 kg satellite, it has grown into a bigger mission of more than nearly a dozen instruments, supported from various ISRO one side and all other spacefaring nations, except 2 of our neighbors. I think you can see the good number of instruments coming from NASA, European Space Agency, Max Planck Institute, JAXA, Bulgarian Space Science, Surrey. I think good number of things came. Rutherford Appleton Laboratory, like that, good number of science instruments came. And this was looking very how graduated on paper. It's still at a metal cutting start. On paper, it was looking very nice. And somehow we could accommodate all the instruments a very compact way, and we are ready to go. And then in the conference when we are talking about, then President Dr. Kalam, and looking at all the things he told, yes, you have so many instruments you are carrying, and trying to show trying to prove no water on the moon, because so many instruments are there. These all the instruments, if water is there, they will tell, but all through you are going to see, because only they are selectively they landed and they could not find the water. Possibly this goes for the global mapping of the whole moon. If all the instruments tell no water on the moon, and yes, unambiguously you will tell, that way it's good. But still, to answer for that you are going, but you are falling sort of 100 kilometers. Is it possible, along with that Indian tricolor flag, touching the moon? I think this is a question he told as President of India in Udaipur. I think this he asked for. Then the whole thing it was totally disarray. Okay, now how to go about? We are all as a project team. We were at the Tirisanku Sarka, like that. Okay, whether to follow what Kalam has told, or forget about that and go for original plan, what to do? Then finally we decided, let us take both. Okay, this is another big challenge, because it calls for, with so much of difficulty, a 10 kg instrument, we are told 25, 35 kg can go. But when if you want to satisfy what Dr. Kalam has asked for, we have to shed another 35 kg of instruments you have to accommodate. That means the system has to be designed much compact. Okay, that's what it called for. Yes, we took the challenge and we went ahead. And this is how the overall satellite configuration came out. Very compact. For this design alone, 2 international awards this satellite got. Okay, and we accommodated all the science instruments as given by ISRO laboratories, and another 6 instruments as originally committed from the NASA or ESA or JAXA or Bulgarian Space Agency. That also we accommodated. Beyond that, as Dr. Kalam asked, a 35 kg instrument also we put here. But this instrument not just jump system. Along with that, we have 3 instruments also accommodated. Here also a mass spectrometer looking for possibility of water molecules in the so-called tenuous atmosphere of the moon. Because moon, nominally people will tell there is no atmosphere, but because the atmosphere gravity being low, and the sunlight, when it's hitting there, the low atomic elements it's keep coming out, and that is also generates a reduced atmosphere during the daytime of the moon. If water could have been there, that also would come out of. So this instrument, when it keep going down, it can sniff through what are all the mass numbers that Venus atmosphere contains, then it can tell. So a very compact instrument, still looking for decisive answer water on the moon. At the back side of that is that actually in my PDR, when I put for this, almost everyone laughed. And I think there's a told this PDR, this sentence is okay. Next, I think you should not have this sentence. It was told by all the top scientists of India. It is there. Okay, but still, I think there's a technical thing we went ahead. But now here, you look at here, this is not a modest satellite. You look at here, this carried actually 15 instruments of 16 sensors. Because you look at here, one instrument will tell us SARA, but that itself contains of 2-3 instruments there. Similarly, NIP we count as one instrument. Within that, there are 3 science instruments. Similarly, you look at KICS. KICS has 3 instruments. Okay, one for the low energy X-ray, and another one for the solar X-ray is concerned, and over and above that, they brought, which nowhere listed there, they brought a processor which has to be qualified, which down the line only came to know, but anyway, having mounted, let us go ahead like that. It has gone through that, so that it proves the space qualification of a very minute processor also happened. Like many things happened there. So that means, engineering point of view, 22 units beside the bus systems accommodated in this. Okay, we are in very compact way we have done that. And now this, anyhow, fast forward, then 2008, so 22nd October, we launched the satellite. And November 8th, I think it reached the orbit there. And November 14th, yes, designated, we have brought the Moon Impact Probe. You look at here, this is the satellite, and this is the Moon Impact Probe. That's been oriented, and it has been pushed towards the surface of the moon. And its own microthruster, it has fired and it reduced orbital velocity. Because of that, no longer it will be there, and as per the gravity, fall down there. During the fall, all the 3 instruments, as I told, one is mass spectrometer, another altimeter, and imaging system, where one is keep taking the photos. November 14th of 2008. Okay, targeted place. This time it is crash landing by design. Okay, and that was gone through that until the last frame. We captured the images, and that is timed as near the pole. Here it is termed as a Jawgardal. First time we are landing, and first time anybody landed that place. Similarly, the mass spectrometer will keep coming down. Something came. I think it happened November 14th when Dr. Kalam was standing in behind us. This happened there, and this is the story of that. Okay, yes, keep falling. 71 kilometer. We have seen on the peak of 18 mass number. Okay, and that peak was keep increasing as the altitude is keep increasing. We keep coming down at this 37 kilometer, and this is at 700 meters above. Okay, when it's coming, that peak is coming. Mass number 18, indicating H2O. Hydrogen mass number 1, 2H2, oxygen mass number 16, 2 hydrogen, 1 oxygen 18. So presence of water molecules has been initially indicated by this. Then we thought, because over and above that, there was another issue. At this point of time itself, we had a failure of a DC-DC converter and Chandrayaan. Somehow I felt one side is happy, another side I was feeling so don't disturb, because in the process of mass optimization, we brought indigenous DC-DC converter to the procured DC-DC converters of 57 numbers. One of them already failed. So all are the similar batch. We are in a deep trouble. Okay, what to be done? Okay, something to be done fast. What can be done something to the past? I think we thought about each one of the people. I think the science team, once again, I was sitting with them. Technically, they have an issue, something we should do. Okay, I think this is like our flight is some problem. Somewhere we have to crash land. What is to be done? Before that, what can be done? I think this is what we discussed among this team. Then we came out. Then what is to be done? At the earliest, what can be done? So what all really required is called for. That requires the whole network of NASA to come to our rescue. Okay, that means satellite cannot live for 2 years is known. So that means as quick as possible. That means is it possible to make use of the satellite 24/7 all through? So that means originally we thought only for the mission point of view we will use it for some time, but now even the instrument operation point of view also we asked for these instruments. I think as a bargain, the 2 instruments we have collected there, they given there. So accordingly, we have got the network support, and that enabled to go for all the instrument operations as effectively as possible. Though one by one DC-DC converters are keep failing. Okay, and that's happened there. So over and above that, Chandrayaan and around that time, a lunar reconnaissance orbiter also they launched it there. So a bistatic experiment of these two, but that also is another way of trying to tell about the synthetic aperture radars, which was carried by our Chandrayaan 1, and there's one carried by LRO working together in cohesion, and we will able to unambiguously resolve the ice deposits on the moon. I think this experiment also has been done together. And yes, first ever the water on the moon, the map have been identified, and this confirms wherever they landed, water is not there even today. So it's not that what they have done is wrong. But only thing is they have selective places only they have gone. But places where they have not seen, US or Russia or other people have not seen, and that places water has been identified. And this is the synthetic aperture radar signature. This is for the M3 signatures, confirming what initially, possibly if this would have been there, this is what Chase would have told November 14th. I think this is how the discovery of water on the moon is basically the suit of all the experiments together. I think it is going for the Chandrayaan way. So this shows the Chandrayaan 1 science team, and you can see all the people around. The Carla Peter is sitting here, and Paul Spodis is here. Our Ashmal. So like that, all the people you can look at the part of the team, and discovery of water on the moon. A celebration has happened there. Our Goswami, principal scientist, all are here. I think Sri Kumar also will be there somewhere. Yeah. Then I think very jubilant. Then I think the first ever time I'm going to US. Okay, it's my personal visit, because my son wanted to join in US, but somehow I'm not for it. But let us go for like that. We went for that. And when the director of Kennedy Space Center, when they realized when I'm there, I think they invited me, though it's a personal visit. When I entered there, this was a welcome board I have seen. It was a very, very remarkable thing. I don't know whether that this scene changed or not. While coming back, my son told, Papa, this place, US, I will come once in a while. Yes, like you are coming as a visitor, but let me study and be there. I think today he is with me. And not only then, all along he was with me only. So this picture is just basically nostalgic for me. Not only professionally, even personally also, it helped me to, for example, today living in a much better way. That I think it's helped me a lot. And yes, by as I told 2009, Chandrayaan failed as expected, because it is not a surprise, because I pretty well I know November 14th when it was Mars moon impact probe went down. I was not really there. Madhavana asked, why you are so dull? You are not coming to celebrate us. No, sir. Somehow I'm feeling one DC-DC converter failed. I think something is wrong. Actually, I was telling that. Then, anyhow, 25th of August, my this is marriage anniversary. You can see how it get connected also. Okay, Chandrayaan 1 failed. And then we thought something else we should do fast. But by the time itself, I think 2007-8 time frame itself, Chandrayaan 2 we started working. So Chandrayaan 1 we took 4 years to get the approval. But Chandrayaan 2, believe me, it is a matter of weeks. Okay, 2 weeks we took to make the project report. A subsequent week, I think the approval has come, and we are running through to make this satellite ready, along with the collaborative Russian request. That 2011. ISRO was ready with the modified Chandrayaan 2 orbiter. This happened there. But Russia requested to change the Chandrayaan 2 configuration. Okay, we are in a deep trouble. We thought something we lost, we can hurry it up, something we can do, something we discovered, we can do, something we thought. I think it's a total team was in a disarray. Okay, but this man was thinking a different way, because Russia has gone out, but now we have to make our own lander, our own rover. It is minimum another 7-8 years. It is an impossible task before 2080. Okay, because it was my retirement days. I know subsequently what I should do, I don't know. So that personal also. I'm not telling it is not personal also, but I get a good opportunity. The opportunity being, we cannot wait another 8-9 years a hardware which has been done. But what can be used? Is it possible to use that hardware instead of going to the moon, going to the Mars? I think, because if you're thinking that way, 2011 end we decide, 2013 it has to go to the Mars, because going to the Mars every month not possible. Every day not possible. Once in 26 months weekly possible. The shortest, nearest thing is 2013. In case you miss that, 16 or 18. Okay, it keeps going down. But we thought we should aim for this. It's possible to do, provided this mission itself we take it. But however, a good number of people have gone to the Mars also, and that experience also available. That experience is good and bad, both. Okay, for example, 51 missions have gone to the Mars. Before to that, not more than 21 succeeded. Okay, that means 30 missions have failed. Not even a single nation succeeded at first attempt. America succeeded on 5th attempt. Russia succeeded 9th attempt. China and Japan was yet to succeed around that time frame. And we are supposed to go to the Mars and has to succeed. And that is a mission which more or less designed for moon has to succeed. I think it's really a tall order, using the PSLV. Okay, because the PSLV launch, you know that this mass of that, it cannot launch beyond 22,500 kilometers. That is the typical elliptical orbit can go. But the travel it has to make is nearly 600 million kilometers. I think we are still not understanding that we have done it. Then you know that now it is a history making the Mars mission is concerned. Then now you look at here after that. Originally, we started with the US that way. Now, this particular mission is 50-50. Parallelly, just I'm coming to go how ISRO also grown around that time frame. Okay, a very ambitious project of NASA, ISRO, SAR project also came out after the Mars and all these things happened. That means now equal players. Okay, when we're talking about when I was Chota boy. Okay, we are looking at that our Apollo missions. Now you look at here, the same NASA and ISRO, equal players. I think you can build some better partner here, because it will launch by GSLV and the satellite will be by us, and one portion of the payload by us. Another payload is there. Of course, it's an ambitious payload. So this almost equal partner scenarios come there, and this is how it happened when July 22nd. Okay, this is when I was talking in. Consul General at July 21st of last year. I just put this view graph I put. Okay, when July 69 how we were, and July 2009 how we are. Okay, by the time we are equal partners. So next day our Chandrayaan was waiting in the GSLV to fly. So this is a situation like that I was putting in the last year's Moon Day. And in the meantime, I also, because this has come, and thanks to ISRO's other things point of view, I had the opportunity to be in Vienna for 3 years, of course, for the chairing committee of the whole, for the various space activities point of view. And there, the proposals, what we have put is, yes, many countries have gone individually. Then is it possible to take forward what Kalam has asked for? By this time, President of you look at here, US has told in 61. Now this President of
Sir, is it okay now? Some hitches are there.
There is some problem, Shadil sir.
Yes, yes. From part of another sir, I think so.
Yeah, extra.
Wait for that, wait for it.
Yeah.
No audio and video is there. Audio is not there. Group.
No, video is also stuck.
I'll make a call to him. Okay.
Yeah.
Okay, I contacted. Just wait for him.
No audio.
I think the video is also missing.
Sir, you are muted, sir. Another sir. Please unmute the mic, sir. The mic is muted, sir.
The video is okay now.
Yeah.
Video is okay. Its video is there. The only thing is that we want to get unmute that. Okay, sir. It's fine.
Hope you're able to see me now.
Yes, sir. It's okay. It's okay.
Yes, sir. Time is running out. Can I?
No, sir. No, sir. We have enough time. You please continue, sir.
Okay. Because sorry, I didn't know about this. Okay. Are you able to see my view graph now? Able to see the view graph?
No, sir. No, sir. We wait for that. Okay, sir. It's coming. It's coming.
Okay.
Okay, sir.
Okay.
Okay, sir.
This you have seen?
Okay, sir.
No, this you have seen previously?
Yes.
Yes, sir. Varun?
Yes, sir.
Okay, I don't know where I left. Anyhow, I continue. Okay.
Yeah, basically I was trying to about evaluation of the system, wherein we started in one way and we are going about. And this last year, when we are celebrating for this 50th year of the moon landing, yes, Sirikumar has told next day we are supposed to be a launch for Chandrayaan 2, but almost we have become an equal partner. 50 years of this, and this is going, and this will possibly will trigger our Chandrayaan 2 possibly trigger return to the moon is point of view. That's why we talk. So that's how I echoed it in the UN Corpus. We should have a possibly a joint mission. That means the international cooperation, rather than individually countries going to the moon for this objective. What Kennedy initially told for US, somebody landing and coming back to prove that. But now 50 years over, and now we should think about slightly different way. That means we should look for we the living human beings of the planet have the responsibility to look for an alternate habitat in the other planets. As President of India, then Dr. Kalam has envisaged for 2050 space vision. I think this has been taught. So that means instead of everyone going for individually for the subsequent missions, is it possible to have a combined effort so that common wisdom prevails across the globe? So towards that, one is technically how it can go. What are the various launch vehicles available? What can be done? What can be done for the other technical things like Chandrayaan and what we have done? A giant missions like that if we go to make a impactful mission. That means this time is not just landing and coming. We must be able to survive along. Okay, that means look for an alternate planet. I think that is the concept. If you do, I think what should be done for that? Various options have been discussed, and that is 2024. Go for a descent element. That means this is still unmanned system, but reasonably ensuring subsequently man has to go. For that, what can be done? That is the thing. And 26 is slightly different mission, and end to end. That means it can go and come back. Okay, that's the way it will happen there. But man was not that. Like more like Gaganyaan mission, but it can Gaganyaan 1 and 2 is something similar to that. It will happen. Moon being a basic, and finally 2028 onwards, we will be able to have a very, very decent long-term human presence in the moon. I think that is the thing. From there, things will start in a much better way. I think this is how a discussion went through that. So towards that, I think you know that already good number of things are happening, and the Starship is getting ready for this to go, and that point of view for the Elon Musk system. But even now, Falcon 9 is a 15-tonner liftoff. It can do many good things. And this is now. Originally, you know that Russia was not having a manned mission. Now, Russia is planning very, very ambitiously to put the Russians to the moon. Okay, and this will become our way of telling is we should have more than a couple of ships, 3 or 4, and if you're in any country, we must be able to launch the things for the humans to go across the globe. That means with the global missions. Towards that, each one has to contribute their own way. I think that's what we thought. And similarly, when we are happening there, long-term thing, astroculture activity also some countries have taken. That somebody like Canada, they have taken and went ahead. And what India can do, I think India also has started its own work. And one of them is a location of how habitat can be done in the moon. So for that, initial works have been identified. That this is basically a place. I think 2 places in India have similar meteorological composition like whatever happening in moon. So something we located is near Erode. Of course, this happens to be my in-laws place. That is also just I'm getting connectivity of how it happens in my personal life as overall thing is concerned. And then we located this thing, and this is almost matching with the unearthed sites of samples, whatever I taken from Apollo 16 versus what has been taken from here. I think this also has been seen there. And we have taken a huge amount of that thing and crushed it to the level of how the lunar samples look like that, and started working. These couple of PhDs already work is going on, the final stages, wherein 3D printed model of lunar structures. I think we thought India can contribute towards that. As I told, Now humans long stay will be there. Long stay, you need agriculture, you need habitat. What can be done? I think this we have abundance of this raw material available, and that making it here, and it's possible to do. And this is works going on already now. Of course, this is nearly 3-year-old. Whatever I'm saying is 3-year-old. I hope by this time something would have been better also would happen also. And this, of course, yes. Every time, not only Kennedy made the first page coming out in the first thing, and everywhere the moon also, Chandrayaan or Mangalyaan or moon-related missions, media takes its own pride and put it, and this came in the first page of Times of India. Okay, and this the full coverage was coming subsequent page, and future outposts of the moon. I think this also came, and now we're looking at weather overall. As I told, SpaceX, Starlink, and going in big way, and China is planning unmanned missions in big way. And May 30th, 2 American astronauts ISS are gone. This is basically prelude to go to the moon. I think this is some sort of a demonstration for this module can go to the moon. As I told you, phase 1, phase 2, phase 3, such that 2025, 2028 back to the moon. That is the thing. Possibly 2030 manned mission to the Mars. As I told, we should have alternate planets for the humankind. This is what is told. So that means present, you look at here, the road travel, sea expedition, air travels, they're very, very safe it has become. Okay, instead of walking, people are going by mobile. Our motor vehicles are going, sea expeditions happen, air travels happening. So this is able to connect the continents. Today, continents are able to connect it. That means oceans are not able to separate the human being. The global village has come because of 3 ways of doing. Once space safe travel has come, so it connects Earth, Moon, Mars, and yes, living planets. I think this is what, yeah, when we're talking about that, roadway, seaway, expeditions, air travel, space travel is happening there. So this will enable connecting the Earth, Moon, Mars as living planets. No longer continents alone. Beyond that also, I think it's possible. I think this is what possibly I envisage at this point of time. So this means what Dr. Kalam has told, alternate habitat for humankind. I believe it is the responsibility of we, the living human beings of the planet Earth, to look for an alternate habitat in other planets. I think at this point of time, probably we need to change even this sentence. Okay, this sentence itself looking very ambitious. As I told, first when Kennedy told, that was looking very ambitious. Now it was looking like it's possible. Now what Dr. Kalam asked for this, I think even this needs a minor correction. So that correction goes something like this. Okay, it is not alternate, it is an additional. Okay, as I told here, we will connect America has gone. America is not alternate. America is an additional continent for humanity, something like that. Alternate, additional habitat for humankind. So I believe, on behalf of all of you, I'm telling, I believe it is the responsibility of we, the living human beings of the planet Earth, to look for an additional habitat in other planets. I think that is what the team Bharat and the people, I think they, if that seed goes to them, just connect me and my second standard versus people like Bharat and other people with this seed thought, if it goes, why not? We cannot do it. Definitely, I think we also can reasonably do that. So that means parallelly, I saw one news item yesterday, gold import 2019 and 2020, you look at here, a drastic reduction. India was the leading importer of gold. Okay, this is for just 1 quarter. 2019 first quarter was 86,250 crores Indian rupees. This year it is hardly 5,000 crores. Okay, that means gold is losing its shine, but moon is shine will start. Okay, shine will go up and up. So 40 years moon landing, discovery of water on the moon, we have done it. Last year, just we missed it. I don't want to touch too much on that, but I think we have reasonably done well. But today, when we are talking about here, we are talking about possibly this will happen, but definitely we are trying to redefine why we have got to the moon, and definitely an additional planets called for various reasons, not only for COVID-19, maybe COVID-25 can come, COVID-35 can come. We need alternative things for various reasons. So 2030, when we are taking 61 years of moon landing, I think definitely we need something, man return to the moon for long stays. Okay, not just to make he lands and coming back in matter of few hours. I think Armstrong and Aldrin stayed only for few hours, matter of few hours only stayed. But I think he was able to stay for long days, and because it's going to be an additional habitat for the world of people. I think that's going to be a possible reality. That means this particular event, it is not only for the US to celebrate, internationally being celebrated for international cause. That means this globe needs an additional nearby systems, and there are definitely exploration missions gives that sense of achievement and accomplishment. So my word is long live international cooperation. So this particular day celebration is nothing but that to happen. And tomorrow, when we are celebrating first year completion of Chandrayaan 2 launch date point of view, definitely this has to prevail, such that India also part and parcel of this international effort. I think that happens. Definitely, I think we have done our duty to the motherland. Anyhow, just 30 seconds. I am being a chairman of National Design and Research Forum. We have announced, of course, every forum, and I tell that, such that this reaches to the people. Every year we conduct All India Student Design Competition, and I'm seeing a good talents are listening, and probably they can contribute from aerospace to textile. I think a good number of things. Taking post-COVID-19 challenge and opportunities. Okay, this is an All India competition, and we have the 3 positions: gold, silver, and bronze medals. And these medals have its own merit when you apply for any big universities. This has merit, and even for aerospace industries. Today, you know that good number of private aerospace industries are simply vying for the people. That's also happening there. So you have a good opportunity. You compete for this thing, and being a part of this, and best wishes for some of you to win this. And the last date being a 5th September 2020, in spite of COVID-19 being there. I think this is what now we are announcing. With this, I complete my presentation. Sorry if I have taken some delay in completing.
Thank you, Anamagiri sir. Sir, for your mission. That's fully accomplished, 100% success. It was the launch and everything. And it's time to call our chief guest, Dr. Sri Manas Baji sir, to speak few minutes that we deferred earlier.
Thank you very much. Can you hear me? Hello?
Yes, we can hear you.
Okay, it's okay, sir.
It's okay? Okay. I'll not take much time, and when people like Dr. Annadurai are speaking, then there is no need for a chief guest, really. And I suppose that there is no match and no comparison to listening firsthand from the scientists who could achieve such stellar heights. Thank you very much for coming onto this platform, and it is an honor and privilege for me to have been invited here. I'll just say a few things to our students. The way I was mesmerizingly listening to Dr. Annadurai when he explained what were the challenges and how they could negotiate with them, and how could they come out with the solutions, and what are their plans for the future. It is all very exhilarating. At the same time, I'd just like to mention a few things to the students who are present here, that when such extremely talented speakers and extremely talented scientists and engineers, they speak about their projects and their visions, sometimes it appears very easy. It seems that, well, they thought and they achieved. But it's not like that, and that is something that I really liked in Dr. Annadurai's lecture. He so nicely and succinctly presented where they were also in doubts, where they had also their points of challenges and how they could overcome it. And I think to any student of any scientific endeavor, it is utmost important to understand that, make no mistake, whatever you are up to, there would be challenges and there would be failures. and you have to sustain, and you have to go with it. And sometimes you will feel it is almost impossible to get over. But the way he showed that from this village up to the heights of the moon, how he traveled and traversed. The same way, if you keep your will running, and if you keep your stamina going on, I think you can always reach up to that point. I'd just like to mention, since it is the Moon Day celebration, it would not be out of place to mention a few things from the original Moon mission. When in 1961 the mission was declared, it was kind of a historical declaration in a sense that there was a space race going on between Russia and America, and it was almost an ambitious declaration that we will put up a man on the moon by completion of the decade. And at that time, no one had any clue what the problem is even, let alone the possible solutions. It was not a difficult solution. It was just an impossible solution. I would like to mention a few things which very recently I went through all the details of this moon mission, and I found out a few very interesting things. That when this project was proposed, people understood that the shuttle has to be a very portable, very reliable, fail-safe computer that will need extremely delicate electronics and computing power. And at that time, the computational facilities just started coming in. And you can understand that it had to be a portable computer-like thing, because that has to go to the moon. And that was the time when ICs also came into being used in the electronic market. And this is the first project that very heavily used the integrated circuits in its own mission. And that also had to attack several other challenges, because at every point of time you need the communication between the Earth station and the shuttle to go on. But what would be the mode of communication? Can there be other reasons of hindrance between the atmosphere itself? Because we know that the ionosphere will reflect any, the electromagnetic waves, particularly the radio waves, that way. So how can the communication go? Those things I had to be worked out. And I came to know about certain interesting things. Even the dresses had to be designed in a different way, because no one knew what are the challenges, what sort of environment they have to face. And that is why there was an international design competition for the dress itself. And ultimately, there were only a few handful people who knew how to even make these dresses into order, and they were not allowed to travel all together, so that if any one of them meets any harm in life, then the whole project can be jeopardized. So you can understand that what Armstrong described as the single step for a man, giant step for leap for mankind, actually that single step also required millions of steps of other people like Dr. Annadurai, who could make this dream possible and come true. So that is what I think our students have to do, and they are very, very lucky that even at this age they are in touch with such fantastic visionaries and scientists from ISRO and the other scientific institutes. So I hope that this will go a long way to take them into their future. I wish all the very best to all of them, and I will not take any more time at all. It is up to the scientists once again to carry forward. Thank you very much.
Thank you, Manas Bagdi sir. We take you as the king of the wisdom at Calicut. That's so that we know the depth of your knowledge. We are feeling that for the past 1 year or 2 years like that. And thank you very much, sir, for competing and joining with us. Thank you.
Thank you.
Yes. And it's the 10th webinar conducted by UL Space Club for the last few months. And the cause of this webinar is not the designers or not the top level. It is from the students. And as the research says, the child is father of man, like that. These students made these things. They developed these things. The idea is that of students. And they have made one more wonderful thing, that the online education is going on in all over Kerala in Kerala education system. But there are few students, they don't have the facilities, online facility to engage these classes. So at that time, this Bharat, Varun and this team made a wonderful competition called Inticho. And based on that, they raised around 50,000 rupees. With that 50,000 rupees, they bargained and they procured around 8 mobile phones and distributed that aid to the most deserving students in this district. That's a wonderful thing they have done. And we are proud of them. And they are behind this, not the scholars, not the other organizers. They are the students. They are making us to do this into the reality. So I think it's good to speak on a little bit on that. I invite Kudisa to stay on this endeavor.
Oh, thank you, Shajil. You are directing to a new direction. This is what Shajil Marsh said is something great work of our student. When this lockdown came, just before the lockdown, February 8th and 9th, we had planned a 2-day space camp, probably either in university or in Sargalaya, a place in near Badagara. One day. So, and many people, PJ Bhatt, who is listening this, he had booked his ticket to Calicut. Similarly, our Dattan, who is our director, OSSC director Shah, who is now in Trivandrum, he also agreed his ticket was booked. But then suddenly the Wuhan students coming to Calicut, getting into Corona, that scare suddenly spread, and I was advised not to proceed further on that. So we were we heartbroken. We postponed it initially. Of course, now it is over. It cannot be done. Now we didn't know what to do. I was talking to the students. Varun came and told me we will have a webinar. He said, I will organize it. He started talking to people, and Jayant Murthy, the very senior professor of Indian Institute of Astrophysics, he brought for the first webinar on his own. None of us did anything for it. And the very first webinar itself kicked off so well. And webinar has become a system now. The 9th webinar is there. The next one is going to be by a ISRO person, Dr. M.R. Shivaraman. Probably he is listening here, he is in this crowd, and he will be talking on GPS. And subsequent to that, our own Dr. Sundarajan, who is here, he has agreed, he will give us a webinar. So like that, it is going to be. So now the idea has come that, webinar can be sponsored. In fact, the webinar has gone from stage to improvement to improvement. It has come to so many things. Now there is a person. We have at the end of each webinar, we have a quiz, and there is a prize. A cash prize is offered by a person. Similarly, now we are thinking that we can have a sponsorship, and then with that money we can buy learning aids like what Bharat and company did, and distribute to the very, very deserving economically weaker students who are denied of this opportunity. So that is what Shajil Marsh said. We are planning ahead and we are going ahead with that. Now, what next, Shajil Marsh?
Yes, sir. It's our turn to introduce our gem of this India. These are 3 scientists and 3 directors are with us, and it's your turn. And you are I think you are the heart of them, and it's your turn to introduce them from your experience and from your heart. The words should be from your heart. That we insist, sir. Thank you, sir.
Many thanks, Dr. Annadure. I don't know how to express our gratitude to you. Very first call from me, after a gap of long years, you received and instantly agreed to come for this program. So I don't know how to thank for that. Similarly, I called up Dr. Rangarajan and requested him. He not only that he said he will come, he advised me, why don't you get Dr. Navalgund I told him, sir, I have not contacted or met him for quite long. Anyway, I'll do it. It's a very good suggestion. He said, don't worry, Kuti, I will talk to you. So soon after that, he called and followed up by my call to Dr. Naval Gun. He also instantly agreed, and that is how we have got 4 giants of ISRO here. Dr. Srikumar also same way. Now it is turn for Dr. Naval Gun, the panelists, to come to the scene and talk. And I will first introduce Dr. Naval Gund. Already has been introduced, but from my side, I'm in the midst of my relatives, so I want to a kind of a dialogue with them. So that way, Naval Gund is known to me probably the very second or third year of my joining in ISRO, in whatever capacity was. Naval Gund began his career in SAC in 1977 and rose to become its director. Before he came as director of SAC, he was director of National Remote Sensing Center, Hyderabad. He entered ISRO after MSc from IIT, Bombay, and he had his PhD from TIFR. More than 40 years in ISRO, he had active service, and he is known as a leader in remote sensing. So also space science and applications. Until recently, he was Vikram Sarabhai's distinguished professor and later honorary distinguished professor. Interfaced many times with lot of international fora, UN COPUS, United Nations Committee on Peaceful Use of Outer Space. He has been a regular person. Similarly, Earth Observation Systems of the United Nations, and ESA, European Space Agency, he interfaced very closely, and he has been through USA, France, China for India's efforts in the area of space. He is an academician of international level. I welcome Dr. Naval Gund to say a few comments about as a panelist to start his comments, please.
Thank you, Mr. Kuti. I hope I am audible to all of you. Let us come back from the moon and the Mars to the planet Earth. Because as Kuti said, I have spent a large part of my professional career in doing remote sensing of the Earth itself. The satellites which go around the Earth with the sophisticated sensors, they look at the Earth, the changing Earth, they look at the forests, they look at the crops, they look at water, they look at snow and glaciers, a large number of natural resources, and see how they are changing. They also look at, monitor many of the disaster-related things like the cyclones, floods, etc. In order to do these things, you require a very sophisticated instrumentation. And many of these scientific instruments, which are very sophisticated, very precise, sensitive instruments which are built and flown on the satellites around the Earth, is what makes remote sensing possible. Now, the reason I'm telling you all these things, the looking at the moon or the planets itself is an extension of this kind of work that we do, looking at the Earth using the same kind of instruments to look at the resources and look at other aspects of the moon and the Mars. But the more important point is, when we want to look at the moon, Mars, other planets, etc., what is it that we are looking for? Of course, there is the curiosity of the person that we want to find out what has been the origin of the formation of these planets. Is it same as the Earth? Are they very different? What is the composition of the material which exists on these planets? What is the atmosphere like on these planets? Are they habitable? So a number of questions which come to the mind of these planets before embarking on the missions to these things. That is very important for any student of science. We want to look at it. Once you identify that you want to understand many of these phenomena, then the question comes, what kind of measurements would you like to do? You would like to make measurements of water, but how much water is there? Or how much hydroxyl molecules are there on the moon? depending upon that, the kind of instrument that you need to design to have that sensitivity is what becomes more important. So all these questions, is there a magnetic field? Because on the earth we have a magnetic field which in fact protects us. But such thing, whether does it exist on the other planets? Is there a tectonism? Should I measure the seismicity on the moon or on the Mars? So a large number of such questions when you ask, then design those instruments to the sophistication that it is required. For example, many people say that did Mars have life? Does Mars at any time in its history have life? So one of the questions that people ask is methane possible on the Mars? Now methane, how do you measure methane? That to 1 part per billion. So the questions that normally one asks is the kind of sophistication in the measurements, in the sensitivity of instruments, and also in the calibration of those things becomes very important. In fact, one of the things Dr. Anadurai said, that although we saw that there was in the mass spectrometer, there was a peak at 18 corresponding to H2O, but we didn't take it seriously. That is because when you carry the instrument up, you might have carried some amount of that yourself. So the contamination, to make sure that you don't take contamination from the earth itself. So all these things are extremely important. Some of these things I want to tell particularly to the students who want to take up their careers best is that you must first understand what is it that you want to do. Technology is very important. In order to go from this place to any other planet or to the Mars, you require rockets, you require a certain amount of thrust, you require deep space communication, you require navigation, you require sophisticated mission software in order to make sure that at the right time you reduce the velocity so that your satellite gets into the gravity of that particular planet and then it starts orbiting. All these things are extremely important and they are important technologically as well. And all those things can be done. But I think most important underlying point is what you want to do in terms of science of doing these things. So in order to do those things, you should make sure that the kind of instruments that you would like to build, their sensitivities, their calibrations, and those things, etc., are extremely important that you should do. And also, it is not necessary that the same thing is applicable to all planets. For example, what you do for Mars may not be true for Venus, because Venus has a very thick atmosphere. So you cannot be using optical instruments to look at Venus, because then you will only see the thick atmosphere and not the surface of the Venus itself. And so you might require a different kind of strategy for looking at the Venus. For example, the new field which has come up, that is the exoplanets, that is those planets which are habitable, perhaps in the other star systems, unlike not necessarily in this sun, but some other stars in some other places. And those exoplanets, how do you find the atmosphere of those exoplanets? How do you measure them? So all these questions become important when you want to take up a career in your fields, etc. So I'm just putting down a few points for you so that you should always look for the basic problems that one needs to study and what kind of measurements are required. And also I would like to say, don't discount the Earth itself. We must look for habitation in other planets, additional habitats in other planets, but let's also looking at measurements which make this planet more habitable. And I would be ready to see if you have any queries later on. Thank you, Mr. Kuti.
Thank you, Dr. Ranganath Navalgudi, sir. Thank you for your blessing. And that's what a very informative talk from your part. And it's most of the students in this group are aspirants to join in ISRO. And next, the aspiration is NASA. And we have a scientist from NASA and ISRO and Indian Institute of Astrophysics, that is Dr. Srikumar sir. And I request Kuti sir to say something more about our chief guest, Dr. P. Srikumar sir. Kuti sir, please.
Thanks, Sidilmash. Dr. Srikumar came to ISRO from NASA. In 1999, he landed ISRO after a decade of working in NASA. I had come to know him even before he joined ISRO because it was my responsibility to do talent scouting to find out where talents are available. So I was interested in the job of inducting suitable people. So identifying, inducting, and the correspondence and the discussions, etc. before his interview and other processes were between me and him. So I can claim that I know him even before he joined ISRO. So that way, Dr. Srikumar is a person who has done fantastic work in ISRO in X-ray astronomy and astronomy, and he was heading space science group of ISRO Satellite Center, and primarily interested in gamma rays, sun's corona, and lunar surface. By being there, he got an opportunity to go to Indian Institute of Astrophysics as a director. He did it. He performed that role exceedingly well for 5 years. Then he came back to ISRO as director of space science program and superannuated from ISRO. But ISRO did not leave him even after that. He was made Professor Satish Dhawan, Dr. Satish Dhawan professor in ISRO, and he continues to be so. Of course, he is not new to our students here. He has been a part of our space camp in Bangalore once, and he did address our students there, interacted well with them, and some of our students know him closely. And he has several publications and awards to his credit, and I request him to interact, to comment on the as a panelist today. Please, Dr.
Thank you.
Srikumar, please.
Thank you, Mr. Koti. Can you hear me?
Yes. Yes, please.
Yeah, okay. You have certainly been very, very helpful in my transition, and I certainly won't forget all the enormous help that came during those days. Today, as you all indicated, is a very important day, and Dr. Annadurai laid out the challenges and the excitement with which we actually pursued the first lunar mission. I will take a slightly different perspective with regard to the way astronomer would look at the moon and planet that corresponds to moon, which is Earth, which Dr. Navalgund spoke about, and then try to take it from there to the wider cosmos. The moon, as you know, could have played a very, very important role in actually producing life on Earth. So there are many, many articles written on this, but clearly moon had a very important role in slowing down Earth, creating a 24-hour day for Earth under which life, photosynthesis, etc. could actually flourish. Moon had a role in actually stabilizing the axis of the Earth and the inclination axis that gives you reasonably relevant but useful seasons without making it either too hot or too cold. Moon had a way, if you believe the origin of the moon came from an impactor that hit that Earth, and then out of the debris moon formed, this impactor could have actually added mass to Earth itself, which gave rise to Earth's capacity to hold back the atmosphere, because of which life today exists on Earth. Iron from such an impactor could have actually gone into the core of the Earth that gave rise to the magnetic field that we now see, which protects us from the charged particles coming from the sun and so on. So moon as a satellite of Earth has a very, very important role. But the larger question that we should, of course, need to understand is our own solar system. And in that context, is a basic question that we all ask: why is Earth the only planet that we know today where life seems to exist? If you look at our other 8 planets, which we have been studying in the last many decades to sort of ask this basic question of is there life elsewhere, Mars has, of course, been heavily studied and continues to be studied. End of this month, there are missions going to Mars specifically look for bringing back samples that will allow us to address the question of biology on the moon. our neighboring planet Venus is also a possibility. But today it looks like a burning hell, extreme pressures of 100 times the pressure on the surface of the Earth, temperatures of about 460 degrees centigrade on the surface of Venus. However, we believe in the early formation of the solar system. Venus, Earth, and Mars may have been very similar entities. They may have had very similar sort of atmospheric constituents, and water may have been present in all of these planets as well. So there is a real need to urgency to understand why Mars went the way it did and Venus went the way it did, and Earth remained this beautiful, incredibly fantastic planet where life actually flourished. This is an important question, and ISRO very recently has also made a decision to really have a mission to Venus, and that's a very important opportunity for many of the young listeners, because when you look at being missions to such places, this will go on for many decades. So I see great opportunities for many of you to get involved in. But the study of Venus has even a larger question that we really need to do in the context of very similar to how Moon played a role in stabilizing Earth and creating life on Earth as well. And that is in the context of asking the Earth, the atmosphere of Venus, which is now heavily dominated by carbon dioxide, about 96.5% is carbon dioxide. And there is reason to believe the Earth's atmosphere was also severely carbon dioxide heavy at one phase, but then later on has transformed into an atmosphere that today supports life. Now, this is relevant in the context of looking at the other topic that Dr. Navalgund talked about, that is the area of exoplanets. Since the last 25 years, astronomers have been very successful in identifying other solar systems, not just planets, other solar systems around other stars. And once we now believe most stars in our galaxy, which is about 100 billion stars, pretty much would support a planet. Now that's a large number of planets, and the probability, this famous probability equation that Francis Drake wrote in 1961, is starting to show that the probability for life to exist elsewhere is not to zero, but something finite. And if that is true, the next question would be to ask how many of them are habitable, and how do we really study such habitable zones. In that context, I think there is a lot of relevance between what we do in the solar system, but that we began with the moon, began with Earth, the moon, Mars, and then on to Venus, and then maybe even the other interesting possibilities of life in the satellites of Saturn, Enceladus, in Europa, and so on. Titan is a possibility where you might have life, not just necessarily water-based, but maybe methane-based. So the larger problem you're trying to address in our solar system certainly has relevance in the context of this really, really critical question we need to know about life elsewhere in the universe. So the playground for many of you youngsters is very, very large. And as rightly pointed out by many of my senior colleagues, this will involve technologies, this will involve science, this will involve biology, this will involve psychology, and a number of issues when you're really looking at even including human space travel to some of these nearest objects. And these processes, and if some of you want to be part of that, and I'm sure many of you want to be part of that issue, that process would require a change in the way we do things. And that is, we really need to stay very, very focused with regard to trying to be as precise as possible. Precisely what Dr. Navalgund mentioned. When you build an instrument, you can build an instrument looking at a blueprint. It would be very good, but then you need to understand precisely how does the instrument work. No instrument is perfect, but knowing the imperfections is as important as building the instrument. That is what is the process of calibration. Once you calibrate it, then when you measure something, you must be able to then interpret that. That interpretation requires bringing in knowledge from a variety of different areas. So a deep study that goes along with your tremendous interest in and excitement with which you actually look at these problems has got to go hand in hand for you to really make tremendous, to make real marks in this field of research and research in space sciences. And I'm sure many of you can do that. And but it's very, very important to ensure that you really do look at it as not just excitement, but a lot of hard work. And you really need to bring that in, understanding, today you learn some basic principles of mathematics in your classroom. Ensure, look for ways under which such a thing can be applied somewhere else. You read something about how some technology happens, you need to understand the material science that actually made the technology happen. So all related matters have to be really looked into, and that sort of an approach would really allow you to really play a meaningful role in this very vast field and vast opportunity that is lying in front of you today. So I think it was absolutely, and from Dr. Anadurei's discussion, you would have got a feel for how fortunate many of us at ISRO have been to really be part of such programs. And I'm sure many of you can be part of it, and the agency would grow leaps and bounds and would be able to lead technologies and science research in the world with many of your participation. I will stop with that. Thank you.
Thank you, Dr. Sigumar, sir, and for your motivation and inspiration to our students and focus on his studies. It will be a good advice to our students. That's the way we are nurturing them also, sir. And our next panelist, eminent panelist, is Dr. S. Rangarajan. He's already part of this UL Space Club and these activities. But we can say he's a veteran person and an energetic person, and we are little bit envious also at you, sir, because of your active involvement on these things, sir. With pleasure, we invite you and invite Kuti sir to speak a little bit more about our Rangarajan, sir.
Thank you, Sajilvash. Dr. Rangarajan, we are envious of you positively, not negatively. See, your presence here in Kozhikode last year made a significant impact on our students, and they continuously demand your presence in our webinars. Of course, you agreed to do it now, and even the Calicut Management Association keep talking to me about your lecture there, and that made that evening a fantastic one. So that way, we are very grateful, sir. Now, as a formal introduction, I have known Dr. Rangarajan for quite long, as almost now 50 years or so. He has been a satellite industry veteran for 40 and more years. And I know him intensely when he became director, Master Control Facility Hassan, and interacted very closely with him for very many things. And I know the worth of the person, excellent worth of the person. And he held important positions in system studies, design, satellite design, mission planning, satellite control, anomaly resolution, and many more areas. And he is known for successive leadership roles he played in public and private sectors. He is a master. He did his masters from IIT Madras and PhD from TAFR, like our Dr. Naval Gund. So, sir, we welcome you for your comments.
Thank you, Kuti sir, and the UL Club people, and my dear friends from ISRO and elsewhere. It, of course, gives me great pleasure to be part of this webinar, because I know the interest with which this whole thing is conducted, and it's amazing. It's something incredible that this standard, even technical quality-wise, is no less than what you get elsewhere. In fact, 2 years ago, I was on this day in US, and we did have a little bit of a celebration of the Moon Day, but I can tell you, the country which sent the first men to the moon, it is not celebrated even 1/100th of what Kozhikode has done in the way it is doing it, even on the 51st year. For me, this July 21st, 1969 is a very important date. That's because on that day, I was having my final super level interview at the TIFR. And what happened, we were intercepted time and again by that whatever radio commentaries or the news clips about the landing and the kind of success of this mission. And when my turn came, it was almost like very late in the evening. I was just waiting. But the advantage was that I was also getting those news items. And most of our discussions at the interview went on to the Apollo mission and what kind of orbits, the mechanics, and so on, as a physics person I was supposed to be talking about. And then I was part of TIFR. And 1 year later, Rangnath Navalgund was in. So it's now 50 years of our being together. It's a great pleasure to know people like that. And moving on, in 1982, when Annadurai came into the ISRO system, I was very much there. We have worked together, very many projects. The very first project of his, the software simulator, is something we had discussed time and again, and I knew how brilliant he was and what a great career he has in ISRO, and that is proven very much. And then his whole journey continues. And when you look at the way India does the space program and other countries, there is a marked difference, which is from the fact that we are 100% applications driven. As Anadre also was showing the news clip of 1999, where the moon mission was being talked about. In fact, I was very much part of the team where we had gone and discussed with Goswami and other scientists, and were defining what should be the applications well before the satellite project and the launch of that and the orbit insertion, and such details were planned later. So the application driven nature is very different from what Kennedy would have set a race between the then USSR and USA for unlimited money being available and somehow land a person on the moon. Whereas ours, there's one small step, but it's a continuing race. You just continue taking further steps and further steps. And another had given already some brief. And then we had two eminent panelists. Navalgund talked about how important is to look at the Earth. And the remote sensing wise, I think ISRO is second to none in terms of the way the data is gathered with a variety of payloads and making it available for any number of applications. So it's only up to the students to even pick some of those ideas. And nowadays, even in webinar form, it's available from Indian Institute of Remote Sensing. Get more and more familiar, and then you will brilliantly come out with new ideas of how this data could be used for something very unique and which is publishable and which can be taken forward. And Dr. Sri Kumar went even further on and talked about the existence of life elsewhere. And there are that way very many challenges. Anyway, I'm going to be talking to the same UL club very soon in 1.5 weeks. So I'm not going to take too much of your time because it's at 5 o'clock. But I want to say that the way to celebrate the Moon's Day is to, first of all, think through whatever ideas have been thrown in the last 2 hours and look at the moon. And then moon, even as a small baby, we are always shown the moon when we are fed by our mother. And that onwards, moon has been a great companion for all our lives. In fact, in TIFR, there was a big group, the last group, which brought the moon samples of the Apollo missions, brought there, and then we were all, at least we were not directly involved in that group, but we used to go and see it and to be very excited how this little matter, which existed in some other entity, is now in our labs, which we can see. Just observing the moon gives you a tremendous amount of inspiration, and that inspiration should go down. And I want to wish Bharat as one of the examples, and I'm sure there are hundreds of them in the same group. And I still remember my wonderful time when I was in Kozhikode, and I'm looking forward to repeating it there, because even during the lunch break, the kind of discussions that we had is something very memorable, and we will keep connected. And I want to wish everyone a great success. Thank you.
Thank you, Ringarai sir, for your wonderful talk and for your inspiration. Definitely that will inspire all the students and that will guide them to the high altitude. And thank you, sir. And now we completed all the panelists, and I think so. And it's the next turn is that of the students. They are waiting for us, and that the student leader and the fellow, the UL Space fellow, Varun is waiting for that. He is coming there with an array of questions to utilize our panelists and the expert speaker. And I invite Varun to come over.
Thank you, Shailja. I'm blessed to get an opportunity to speak here. I just want to speak to Dr. Malsamy and Adurisa for just a 30 seconds. I just want to express my joy to attend his class. Uh, First time I heard his name from a quiz competition when I was studying in third standard. I just heard a question that who was the project director of Chandrayaan-1 mission, and I didn't get the answer. But that time uh, I got a name, that was Dr. Malsamy Annadure, and now I am talking to him, and I can't express my happiness because I'm at that's at the extreme level. I'm really happy, sir. So you're from Tamil Nadu, so I just want to tell you two words in Tamil. சார், உங்களை மாதிரி ஒரு பெரிய உங்ககிட்ட பேச முடிஞ்சது என் வாழ்க்கையில ஒரு மிகப்பெரிய வாய்ப்பா நினைக்கிறேன் சார். ரொம்ப நன்றி சார். எங்க மாதிரி இருக்கனா சின்ன குழந்தைகிட்ட வந்து பேசுறதுக்காக ரொம்ப நன்றி. இது வந்து மறக்க முடியாத ஒரு வாய்ப்பு, மறக்க முடியாத ஒரு நிமிஷம். தேங்க்யூ சார், ரொம்ப நன்றி சார். Sir, the questions. I just collected 50 plus questions from the chat window, and but we have not time for that. I just selected 12 questions from that. Can I ask that, sir?
The only problem is that Anandri sir just messaged that he has to leave. That's why. And I think you present there. We have eminent panelists are available there, and we can discuss it now. That may be good. And he messaged me, and Arjun has to attend some more things. That's why he take permission to leave. That's the thing situation here. But we have an open forum. Let's try here. We don't want a complete answer. I think it's we are creating an environment for further studies and further thinking, and it's always sparking and triggering environment we are creating. In that sense, we can ask and discuss questions. I think our honorable guests are here. Ragaraj sir is there, Srimar sir is there, Navgun sir is there, and even Padmanabhan sir is also watching us. And we are here, and we can construct a response, positive response to this question. I think like that. Okay, thank you. Continue.
Before starting, I just want to say, please forgive me because I avoid a lot of questions, lot of good questions when I'm selecting these 12 questions. Please forgive me. We are short of time, so please forgive me. I will start now. First question is from our US Space Club member, Abhiram TP. First question. Cryogenic engines were the secret to the success of the Saturn boosters that amazed the world in the late 90s. But we have not been able to stabilize the success of our cryogenic rockets, the GSLV rockets. Why did we fail in this? So this is the first question.
I request eminent panelists to continue with this, sir.
I don't think we have already had success with the cryogenic engines, both at 12 ton and as well as 25 ton cryogenic engines, which have been used in GSLV Mark II and now more recently in GSLV Mark III. Obviously, of course, you require to go much higher, but I think that time will also come. We do have success with the cryogenic engines. I think that's
perfect.
Yes, the next question. In 1981, we find some rocks near Allen Hills in Antarctica. It was really the rocks of Moon. If it is a meteor shower from Moon, how will it came up from the surface of the Moon?
Okay, maybe I will take up that question. Rocks that we do see a large number of meteorites falling on Earth. As a matter of fact, on a given day, about 10 tons of material fall on the surface of Earth, but not all of it makes it to the ground. There are sometimes dissipating in the atmosphere as well. But those that fall on the Antarctica coming from the moon, the question is how do they come from the moon? And that is because the moon doesn't have an atmosphere. So just as rocks are falling on Earth, they're also falling on the moon, big rocks, and these actually eject material from the moon that escape the gravity of the moon, and they're always moving around. And under certain conditions, they enter Earth's atmosphere, and they end up landing in various parts of the world, including that Antarctica. And Antarctica is a great place to look for them because they stand, the contrast is very, very large against the white snowy background. So rocks do come from the moon through the impacting process, which the whole solar system is being affected by. I hope I've answered that question.
Yes, sir. Next question is from Mr. Azad Raji. What were the main obstacles in launching a spacecraft to the lunar surface?
I think your question is probably not framed properly. You meant the
Soft landing.
Soft landing. I think Sri Kumar can address that.
I mean, the soft landing on moon is much easier than, say, soft landing on Mars for various reasons. But let's just take the moon issue. Moon soft landing is not as much of a challenge if we know precisely the potential and the gravitational potential against which the incoming lander is actually phasing. So we do, over the last many decades, we have mapped out the potential of the moon. So we understand it at a great level. But as a lander comes closer and closer to the surface of the moon, which is all happening autonomously, where you don't really send a command, see the reaction, and then adjust it, etc. It's happening autonomously. There is a lot of information that is being fed back from the sensor back into this control system, and then you adjust various elements like throttle, speeds, etc., direction, attitudes are all adjusted under which you actually do the soft landing. So the technique is to really ensure that we get all of this in a manner where it is within the controllable limits that we had originally planned for. So the challenge is really making sure that all the small uncertainties that are associated with each of these parameters is minimized to the bare minimum. This is not trivial. It still remains a challenging thing, and we were very, very close with our Chandrayaan 2, and clearly with Chandrayaan 3, I'm sure we will have a successful soft landing.
Okay, so next question. Previous day, I heard about a huge machine called aerospace autoclave. What's the function of that machine, sir?
Autoclave.
Aerospace autoclave. Autoclaves, I do not, I myself not very sure about what is an aerospace autoclave, other than autoclaves that are used for various, cleansing purposes, various other, as part of the material processing issues, etc. They use it. I don't know if Dr. Navalgund knows anything else.
No, this was recently built by the fabrication facility at Nasik, and it was meant for Vikram Sarabhai Space Center. They said, I think it took some 2 years or something to reach from Nasik to Trivandrum. That's why it became a news in the papers. This definitely is something they must be using for cleansing purposes of their rocket parts, etc.
They use it quite frequently. It was been there for a while. It's no new technology.
No new technology.
Okay, so next question is from Ashwati. I hear that some space agencies like NASA investigates about dormant viruses. I don't know about this in ISRO. Anyways, can it apply in the cases of COVID-19?
No, I think you go ahead with the next question.
Yeah, I think it's good. All right.
So, how we can change the moon's soil into the oil which is edible for agriculture?
No, I see agriculture in space or for that matter on other planets, etc. is a very new concept. It is being done, of course. Basically, for any agriculture, you require a certain amount of light radiation and certain amount of nutrients. So what people have been doing is to use a certain material in space where they have auto regeneration. That means the waste material itself is fed back and they create the agriculture. That is how even in Mir station, the Russians did grow wheat. And even now in the International Space Station, they are growing many things, etc. In fact, there is a small, this one, they say that the astronauts in the later years will eat the rabbits, and rabbits eat the, basically the spinach which is grown there, and then the rabbits are eaten by the astronauts, and the whole excreta will go back to the spinach, and it's a big circle. I mean, that's what people have been thinking of. There are some, in fact, experiments even now being conducted. But using just the moon's soil surface, it is not possible. Of course, there is light, but there is no other ingredients which are required. Carbon dioxide. Okay, so.
So next question is from Nandana KP. As part of the Apollo 12 mission, the camera from the Surveyor 3 probe was brought back from the moon to Earth. On analysis of the camera, it was found that common bacterium Streptococcus was eliminated on the camera. What about that, sir?
There's too much details there.
This claim detection of this material brought back from the Explorer, the Surveyor 3, was reanalyzed, and about, I think, 7-8 years ago, they concluded from the investigation that this is based, this has come from laboratory contamination while they were re-examining the return sample. So it just shows how careful you need to be with regard to searching for traces of life, and you always have to be very, very sure that you're not looking at a contaminated sample. So this was a case of a contaminated sample.
So next question is from Mr. Abhinav B. George. Why all rockets are painted white?
The white reflects much better. Thermally, you can control the system better. So that would be one possible reason.
Okay, sir. Next question is, can you describe about the slim spacesuit of SpaceX?
Spacesuit.
Sir, it's look really slim when we compare to the spacesuits of other agencies. I think that's why he asked that.
You mean the newly designed spacesuits that SpaceX people are? Clearly, there's advantage in that. This comes back to how a private industry would look at without the conservatism of an agency, but for design of an element. SpaceX, of course, as a private agency, is not burdened with many of the constraints that a government agency normally does. So they come up with a very innovative design that is shown to be very effective and is designed after many decades after the last set of spacesuits were actually seriously designed. So in that sense, it's a natural evolution for suit design, and clearly all of this requires some time to really ensure that this is indeed the best design. But this is part of an evolutionary phase of the suit design, is what I would say.
Okay, sir. Next was a question from Dhruv Nayak, but it was a directly question to Dr. Milson and other. Do you want me to ask that question?
You can ask, but we don't know whether we'll answer.
It was a direct question to him, sir, because the question is, was there a time when he had experienced a failure while working any ISRO missions? If so, how did you deal with it? That was the question, sir.
I can answer that if you want.
Yeah.
Because we have had so many of these missions, and we have had any number of failures and partial problems, challenges, and these contingencies have been gone through, I mean, the most classic example, which is quoted very much, and you can watch the YouTube video where President Kalam sir is giving the explanation of what happened when the first SLV flight did not really go beyond the first stage. So therefore, you'll notice that we always come back with the right lessons, because the ISRO has a culture of looking at the failures very, very formally with good review committees, and then that is fed back into making our future systems better. There's nothing like a success and failure as just 1 and 0. No.
Okay, sir. Next question was from Navneet. Does design of a space probe vary with the factors like orbit it is placed or field forces they are placed in?
Design of an Sorry, I missed hearing that.
I think, are you saying that, yeah, design certainly would depend on the orbit. For example, whatever you are going to place in the LEO, the low Earth orbits, there are different kind of environments, and then you have to take care of that. And when you go to, let's say, geostationary, you have some other kinds of issues there when you're talking about interplanetary. So the design obviously have to take into account the orbit or the altitudes and the kind of environment in which the satellite is going to be placed.
Okay, sir. Next question is from respected Shivaraman sir. Water is a scarce on the moon and there is no rain too. How can vegetarian grow on it?
There is water on the moon, as Dr. Nadure tried to tell you. And one of the things we found is there is widespread water on the moon. However, it's not enough for you to drink. It is not in that manner. It's in the form of ice that may sublimate also during the solar presence. But at the poles of the moon, where you have craters that have never probably ever seen sunlight, water could exist in the form of frozen ice. And one of the key objectives of the future missions, including some of the ones that ISRO is also working on for the future, is to look for presence of water ice in the surface, in the poles, in particular the south pole of the moon. So, if assuming you can actually get to this water, then that water can act as a source under which we can actually use it for producing oxygen or fuel or whatever that future generations would like to do.
But to do agriculture, you also require carbon dioxide for photosynthesis oxygen. So I think it's not just enough to have water.
Just for information, Dr. Navalgund, this question is from Dr. M.R. Shivaraman, who is in the geodesy. Your geodesy.
Of course, Zach.
I know. I saw that Manjari I saw the
Exactly, yeah.
No, I know. When you said GPS, I knew that it is only Shivaraman.
You all know him like that.
He's going to talk to us next Saturday to our students.
Yeah.
So next is the last question, and it was also a direct question to Naduresha. But now I would like to convey, or I would like to ask that question to the legends. You guys, the legends of ISRO, as a representative of all students of India. The question is, what would be your message for upcoming generation and the junior scientists of ISRO?
Junior scientists of ISRO. No, I think Dr. Sri Kumar mentioned it in his comments extremely well. He articulated well. You have to have a focus on what you want to do and study in great details at great depth. See, not only you need to have the question of scientific curiosity, but also you need to have all the necessary knowledge that you need to have, curiosity to do those things, to take it forward. I think that's the main thing that you require. Not to just depend upon a certain ready-made cooked food which is material elsewhere. You have to do many of the creative things yourself. I think that is the message that I have for most of the students.
Okay, sir. That was the selected questions. We have a lot of more questions, but we are having a short of time. So I just want to conclude the question answer session now. Once more, I want to say that please forgive me because I avoid a lot of questions. Sorry. And now over to Shailesh sir. And thanks for my such
Thank you, Varun, for compiling this large number of questions and selecting. It's a very good task, and we are blessed with the panelists, and they deal it very well. And we are taking the words of Dr. Navalgund. That's a study in detail, in depth. That should be the focus of our group. I think the new group will. That's the main aim of this gathering, UL Space Club, to make a self-motivated environment with that great direction. And with your blessing, we think that it is possible for this upcoming generation, sir. Okay. Now it's our turn to the concluding session is coming, and it's next is the review session that is done by Dr. Santosh EPA, the coordinator of UL Education under ULCC. I invite Sandesh sir to join the audio. Welcome, Sandesh sir.
Yeah, thank you. Good evening, all dignitaries. Sorry for some network issues from my part. I'm compelled to hide my face. Video is not working properly. Today was a remarkable day where knowledge, passion, and intellectual delight flows across the generations. And today is very remarkable for the student participants, UL Space Club, and ULCCS. ULCCS, as already mentioned by the introductory session, is a cooperative which was founded in the year of 1925 by Vagbadananda Gurudevan, the greatest reformer, social reformer, and spiritual leader in Kerala. And now we are supporting almost 20,000 families, even though our main area is of construction. Under the leadership of current chairman, we have diversified into various fields such as IT, and we own the only IT park under the cooperative sector. So ULCCS is very glad to be part of such initiatives where young minds are nurtured. Okay, sir, coming to today's event. As part of the Moon Day celebrations organized by UL Space Club and Balabhumi, we witnessed an interesting discussion right now, starting with the introductory sessions from Bharat and Kuti sir. The session started with an informative presentation by Dr. Annadure, former director of URSC ISRO. It was quite helpful and encouraging for students, and it was comprehensive. It covered the history, what has happened throughout the last decades, and what is the future of space-related inquiries. And he stressed on matters related to students, how they should learn, how they should approach the subject. Such all matters has been quite well narrated in his speech. And I think it will have an everlasting impression and influence on hundreds of students who have participated in this discussion, either in the online mode or through Facebook. The online discussion has its own limitations. I felt the purpose of the discussion has been met without any compromise. The talk was quite interesting and it grabbed the attention of the audience well. It was evident from the plethora of questions asked from students. The comprehensive and convincing mechanism of presentation was effective by all means. And in the following session by Bagchi sir, he beautifully summarized the spirit and passion behind the speech of Annadure sir, followed by Navalgund sir, where through his remarks on Earth, he stressed the importance of understanding the Earth and its resources, and the importance of protecting our Earth, followed by P. Srikumar sir, where he further explored the great opportunities before us, and he pointed out the novel future directions for students and the right and how the right approach for making big things in space. And finally, we have heard so much about Rangarajan sir and his beautiful presentations. He communicated the spirit passion and intellectual delight of being a space scientist or technocrat. Thank you, sir, very much. And finally, I would like to congratulate all students who had participated, technically arranged, and make this webinar a grand success. Thank you, and ULCCS is anticipating more cooperation from great scientists like you. Thank you, sir. Thank you.
Thank you, Sandesh sir. And it's a last session of our this great event that we can say after success, after completion, we can say it was very great, and it was a live stream in the Balabhumi Facebook channel, and a lot of people are watching all over Kerala, and still it be there as a history, MA history, and we can say this is prime one that happened in Kerala, and that's watched by all over India. And I invite the Sri P. Damodaran sir to express his vote of thanks on behalf of ULCCS. Damodar sir, please come. Damodar sir?
Shajil sir, I think there is some technical problem.
Okay. Then that also be done by Sandesh sir also. Please do it. Okay.
No, I will call Damodar sir one more.
That I am doing. That I am doing. For that, I think our patron, chief patron, and the mentor of this youth club, Kuti sir, has to add some more thing. Then by that time we can wait for Damodar sir. Kuti sir, please engage.
Yes.
You see, we are already, it is too much time. Already we are too late. Let us close the session. We will get some other opportunity later. So let our Damodaran Mash, please come. Damodaran Mash.
He joined now. He joined now.
Yes.
Please.
Hello. Can you? Okay. Today, US Space Club in collaboration with Balabhumi is celebrating the 51st anniversary of the historic event, Man on the Moon. First of all, I would like to thank all the persons participating in this program and toil for the program to be a success and a remarkable event. Our honorable guest, Padma Shri Dr. Annadure, pronounced as the Moon Man of India, made a rousing speech for us. This made this occasion very glorious, and I am sure the space curious students were waiting for such a moment. We have great pleasure to thank you for such a marvelous speech. I once again extend our sincere thanks to Padma Shri Dr. Annadure, sir. Regional Science Center and Planetarium is ever since a cooperative factor of UN Space Club and worked on the IDEA project. Now, the curator of Planetarium, Sri Manash Bakshi, is our chief guest. We are grateful to you for giving a splendid speech. We extend our sincere thanks to Sri Manash Bakshi. Sri Rameshan Paveri, chairman of ULCCS, who presided over the function, is the backbone and strength of Vatpadanda ID project and UN Space Club. He is the creator of all opportunities and facilities that the students experiencing through these projects. We thank Sri Rameshan Paveri very sincerely. Then I would like to thank the former directors of ISRO, Dr. Naval Gunj, Dr. P. Srikumar, Dr. S. Rangarajan for participating and giving valuable comments. Thank you all the three eminent persons who inspired and encouraged our students. Then I thank the Balabhumi management for arranging prizes for competition winners and Sri Santosh Valikod, the Chief Sub-Editor Balabhumi, representing Balabhumi for delivering welcome speech. We thank Sri E.K. Kuti, former Director of ISRO and the soul of UL Space Club and the advisor of Vatpadanda project. He is the person who toiled to get eminent persons for this program to make this event a prestigious and remarkable one. Once again, I thank Sri Kuti sir sincerely. I thank Dr. Sandhu, coordinator who made me of this program, and Master Bharat Sridhar, who gave an overview of Space Club. Then thanks to the brains behind this program, Sri Shadil UK, teacher at DHS Balashiri, Master Bharat Sridhar, Master Varun, Master Adil Krishna, who were working days and nights for the success of this event. After all, we would like to thank all the persons participated directly and viewed through online streaming mode. I expect further cooperation from all. I am stopping my words. Thank you all. Thanks.
Thank you, Damodar sir. Here we conclude the 51st anniversary of human conquer on the moon. That's a wonderful thing. That's ever memorable. Thank you all. Okay, thank you.
Thank you very much for sitting until the last, Dr. Navalgan, Dr. Sri Kumar, Dr. Rangarajan. What a nice evening. Very nice. Very nice. Thank you. I don't know how to express our gratitude.
Thank you. Bye-bye.
Thank you. Bye. Thank you. Bye.
Thanks to all of you.
So, Varun, what else?
Yes, sir. Yes, sir. Our
So
programs are...
everything went well according to you?
Yes, sir. Yes.
Kuti sir, I think we should have informed them about the next program.